It's to start. Thank you. Dear colleagues, on behalf of the Board of Directors of the HAICTA, I would like to welcome you to the 10th International Conference on ICT in Agriculture, Food and Environment. As you know, HAICTA is a member of EFITA, the European Association of ICT in Agriculture, and our purpose is to promote the research and teaching of information and communication technologies for the benefit of agriculture, emphasizing on the applicability of ICT solutions and innovations to real industry cases and their respective challenges. During its 20 years of operation, HAICTA has organized scientific events and conferences. After organizing the HAICTA conferences in 8 different cities around Greece, we decided to return HAICTA 2022 back to its roots in Athens. At this point, I want to declare the opening of the conference and to wish to all of participants to have 2 days of fruitful cooperation, networking, and useful conclusions. Thank you very much for being here with us. And now we will start with the second session, in which I'm the chair. So, the first presentation is entitled Considerations of Multi-Purpose Agrobot Design Towards Automatic Skillful Viticultural Task, a study in northern Greece vineyards. The presenter, I think it's Theodoros Gibrizis.
Morning. Presentation. Okay. Can I also have like the notes that I have in my presentation?
Can you please help him?
Μπορούμε να βάλουμε τις σημειώσεις που έχω σε κάτι διαφάνεια. Okay. Good morning. My name is Theodoros Gibrizis, and I'm a PhD candidate in Aristotle University of Thessaloniki at the sector of viticulture. Today, we're going to discuss about our project and our work that we are doing right now at the university, which is about some considerations for a multi-purpose agrobot design towards automating skillful viticultural tasks. Our study is based in northern Greece vineyards. So, the quality of wine is being directly affected due to the terroir of wine and also affected by the viticultural practices that are being performed at the vine. The demands of the market that they want to produce more wine and better wine, it's also wants more labor, but the lack of labor needs also some viticultural robots to contribute and help like harvesters and growers to produce better wine. So the main problem is that we don't have a lot of people working on vineyards, and now to produce better wine we need and we want to design an agrobot, an agricultural robot that will be able to produce good quality grapes and perform all the viticultural practices by itself or by collaborating with another agro-robot. Already in agriculture, we are using robots like to perform some viticultural tasks like pruning monitoring, spraying, and etc. But more skillful tasks, like tying or shoot thinning, are not being performed by agrobots. So, winter pruning, it's a very important viticultural practice due to its physiological and productive effect on plants. Pruning can be performed either manually or automatically. The harvester and the worker holds the cane with his non-dominant hand and cuts it free with his dominant hand. This task, traditionally, is performed by experienced workers. After the pruning, there are selected 2 new canes. Each cane is being tied down on the wire and with this tool. This is a skillful operation because at this stage, the vineyard is really tender. So it's really difficult because if you bend it on the wire, it's gonna be very tender and maybe it's gonna break. So this task is being performed after pruning. In shoot thinning, it's been decided how many buds the whole vine can carry. The workers select how many buds the whole vine can carry, so they counted the buds, and with a sharp move, they remove them from the vine. Less shoots equals fewer grape clusters with more concentrated flavors on the vine. Leaf removal, it's about the modification of the microclimate of foliage, so it equals better air circulation on the vine and also better sun exposure. Basically, leaf removal varies depending mostly on the grape variety. In general, less leaves are being removed in white grape varieties, and more leaves are being removed in red grape varieties. This task is usually manually performed by hand, but also there are some machines that they can be attached to a tractor and perform this task. So, cutting shoots at the sides and above the higher vine at flowering results more carbohydrates and more nutrition on the grape clusters. This performed by a secateur, a folding secateur, either attached on a tractor, either it is held by a worker. Usually, in the modern vineyards, which are vast and linearly structured, the top and lateral shoot removal is being performed by a tractor. Weed removal, it limits the competition for water and nutrition with the vine, and also it maintains a good microclimate and soil fertility for our vineyard. This task is usually performed with mechanically performed with a weed removal machine attached to the tractor. Spraying is being performed for the treatment of diseases and insects of the vine. Often it's also performed preventive on the vine, and ideally, spraying is being performed first of all in the underside of its leaf first, and then from the top of the vine down to the bottom. And lastly, the last viticultural task that they are performed during the year is harvest and cluster thinning. Cluster thinning is coming first from the harvest. Cluster thinning is like all the branches that are uniformly ripened from the grape, they are being cut off and thrown, so we can help the rest of the grapes to mature better and perform and have a better quality on our grapes. Harvest is the collection of all fully ripened grape clusters, and both tasks are being performed manually. Since last year, we are working on a project, it's called Technology-Free Skillful Viniculture, and it's about the collaboration of 3 different robots, so they can perform either by themselves or either collaboratively those viticultural tasks. Those 3 robots are being also collaborative with the drone. The drone is only used for mapping, and the 2 out of the 3 robots are wheeled and more skillful, and the third one is a carrier. Those robots has at least 1 robotic arm attached on them, and we can also have like a 5-finger robotic arm or some and other tools mounted on the robot so they can perform all these tasks successfully. For the task of pruning, we are selected to have like a cutting tool and a holding tool attached on the robot, so they can actually with one hand cut the cane, and with the other tool they can cut the cane. The biggest challenges and limitations of this task are the cane determination from the robot. It's cutting the cane without injuring the vine, cutting and holding simultaneously, and removing wood from inside the vineyard. Tying, as I said before, it's like a very delicate task to be performed. So for this task, we selected to be able to perform it with the tying tool and the holding tool, as you can see in the photos. This 5 fingers robotic arm can perform like all the tasks, like it's a normal hand of a worker. The biggest challenges and limitations of this task are cane detection as well, wires detection. It's how the robot will be able to bend canes without breaking and injuring the vine, and also tying the cane and the wire together. In shoot thinning, we will be able to perform this task with a robot, again with the use of a 5-finger robotic hand. And also, as I told you before, the robot will have like cameras and all these informative systems that the robot will be able to recognize grapes and leaves on the vine. So with this 5-finger robotic arm, we will be able to recognize the leaves that we want to remove from the vine. But the challenges and limitations of this task is to adjust the number of buds to remove buds without injuring the cane, and also to determine how many buds are on the vine. So here we can see some photos for the leaf removal tasks. The first photo is from a drone flying on a vine. And if you can see, like those purple things on photo are the grapes. So with the drone, we recognize where the grapes are on the vine. And then we can select how not to damage the grapes. For the task of leaf removal, it can be performed either with a grasping tool or with 5-finger robotic hand. This viticultural task can be performed either from 1 robot or 2 robots, but the limitations and the challenges of this task are a lot. I mean, we have to figure out how the robot will grasp the wires or the branches, what will be the applied torque of the robot, how we're going to remove leaves without injuring grapes, and how we determine the percentage of removed leaves based on variety. We also have to perform a uniform leaf removal, and also the robot has to detect the foliage and the density of the vineyard. For top and lateral shoot removal, things are easier. First of all, we thought of that we can use a secateur tool or a trimming tool or a topping machine. The only problem is that we have to adjust the tool to the vine height, and also we have to remove shoots without injuring the vine. For weed removal as well, we are thinking of using an under-row weed control, but at this type of task, we have more challenges, like how we're going to manage with under-row weed control, how we're going to cut the weed between rows and between vineyards without cutting or injuring trunks, and also to adjust the tool to the desired height, and also trunk and structure detection and avoidance. Spraying is also a little bit easy. The end effector tool that we will choose to perform this task is either a moving spray tube tool, either a moving multiple spray nozzle tool, either a customized spraying machine. And also we have to adjust the tool to the desired height and direction or orientation to spray, and also to see the restrictions of pesticide diffusion. The last task that we want robots to perform is harvest and cluster thinning. This will be performed with a simultaneous cutting and holding tool, either with a cutting tool and a holding tool. This task probably is going to be performed with 2 robots. The challenges of this task are to determine the degree of maturity of the grapes, which the robot will be able to perform it with the cameras and recognizes from the color of the grapes what is their maturity. Also, we have to determine the branches we want to remove, and also the stem branch detection with environmental noise. It's a little bit difficult. So we also want the robot to cut the cluster, and with a non-dominant hand, hold it because we want to move it on the crates and then move it on the winery. So in conclusions, it's a multi-purpose robotic system towards automation of a set of basic viticultural practices. The innovative thing that we want to make is to make 3 different robots that collaborate together, but they can also work independent. And in future work, there will be more informative system structure for terms of software and hardware technologies. Thank you for your attention. Excuse me for my presentation. I thought that I will have my notes with me, but I'm trying my best.
We want to thank Theodoros Gibizis for his interesting presentation. Are there any questions? Yeah. Please just wait for the microphone, because we have also live streaming.
Okay. Are these robots field tested? What you have shown us, I couldn't understand if they are field tested. Thank you.
You're welcome. Those robots are field tested, but not in all the viticultural practices. As I told you, we have, since last year, the design of the robots. So we are trying to figure out how we're going to perform every task. And step by step, we design the robot. Yet, we only figure out how we'll perform the shoot thinning, only this task. But we are taking information about the vines, about the maturity of vines, about which leaves the robot should remove, and all the things, how they should be done. And we are in the phase of structuring the robot. I mean, we are now building a robot. We have tested on the field, but not in all of viticultural tasks.
Are there other questions? No? Thank you. Thank you very much.
Thank you. You're welcome.
So, we will go to the next presentation. It's the integration of Sentinel-2 derived phenology with the soil grids of ERA5 meteorological data of operational crop yield forecasting under large-scale applications. And the presenter is the Emmanuel Lekakis.
Thank you, Mr. Chairman. Good morning, ladies and gentlemen. My name is Emmanuel Lekakis. I'm an agriculture engineer, and I am the head agronomist in AgroApps PC. So what I will be presenting today is a joint effort of 2 companies. One is Melissa, which is a pasta company. Probably you may all know it. For those who do not, it is a very big pasta company here in Greece. And on the other hand, we have AgroApps, which is a company that develops solutions for the whole agri-food sector, whether this is the public or the private sector, starting from farmers up to consultants, companies, etc. So this joint effort was actually to investigate whether a model, which I will show you later, which is the aquacrop model, could be used operationally, let's say, for predicting and for estimating yield under a large-scale application. Some may wonder, why is this innovative? I would say that this is innovative business-wise and, of course, operationally-wise, because the importance of yield estimation is very grave. It's very important. So, yield forecasting can be performed near real time within the season. So we may use several different data in order to predict yield within the season, meaning that we can have for every month a new prediction of yield, also incorporate new data or new meteorological data, use, for example, seasonal forecasting as well to drive different kind of decisions, for example, strategic, tactical, or even operational. Another part is yield forecasting in the long term. So we need projections. Projections are very important to see for example, the sustainability and the driving of weather and climate change in yield estimation. So you can see here, for example, we have applied the aquacrop model in order to receive the yield and predict the yield using Cordex data. Cordex data and the RCP 2.6 climate scenario, and we can see an extreme variability in wheat yields. So what is the importance of yield forecasting at, let's say, a regional or national or a pan-European scale? So it is not of mere chance that there is an initiative, a research center like the Joint Research Center and the Mars Project for, let's say, investigating, analyzing the sustainability of agricultural systems, the productivity of agricultural systems, and let's say, of course, why not, food security. So what happens when something goes wrong? For example, what happens if we have political turbulence or a war, for example? So you can see here the Mars project estimates the yield for two sectors, let's say. One is the European and the other is the Russia, UK, and Ukraine and Kazakhstan. So what happens if something goes wrong and then we face probably a food crisis? So this is where strategic decisions need to be taken. So this is a very important application for yield estimation. Strategic decisions meaning, of course, policy formulation and planning, subsidize new crops. For example, what we expect to happen in Greece is to subsidize more soft wheat. And then, of course, you can see here the dependence that we have from other countries, and this is something that we need to tackle with new policy formulation, and this where yield forecasting is very important. The importance of yield forecasting at the food industry and the food and agri-food industry scale. So let's take, for example, Melissa. It is a pasta company and makes contracts with the farmers. So you can see here throughout the cereal value chain, we have the farmers' contracts, and then they need to estimate not only the storage, but they need to estimate market expansions, of course, expansion into new areas, which is very important, the supply from grain traders, so they need to see how much they will achieve in terms of yield, and then plan for the whole year. And so they need very much, this is what they need. They need yield estimation within the season, and of course, they need projections. And what about at the farmer scale? So we have seen strategic decisions, strategic planning, and now we are at the tactical and operational, let's say, level of planning. Tactical and operational. Operational is day-by-day planning. We have, for example, we run a model, we simulate soil moisture, and then, of course, we can make operational decisions like irrigation scheduling. And then we have, of course, the yield estimation within the season or seasonal forecasting, and we can see that it is also very valuable for variety selection, early varieties or late varieties, based on weather, sowing date selection, fertilizer, etc. Of course, as well, it is selling and planning for the farmer as well. So these are tactical and operational decisions. So what we actually did here is to exploit a number of parcels that together with Melissa, we worked together with Melissa to simulate the yield of 184 parcels in 2 areas, in Kozani and Larissa, for 2 growing seasons. The growing seasons were 2019 and 2020, 2020-21. The sowing dates were the usual sowing dates in both areas, in Thessaly and Kozani, starting from late October until early December. The parcel areas that we have were less than a hectare and up to 10.5 hectares. And what we actually wanted to see is how this could be, let's say, affordable and business-wise logical, and see if we run the model. Aquacrop, for example, is a model that combines robustness on the one hand, and on the other hand, it combines a medium, let's say, data intensity, because we have models that require a lot of data. So we wanted to see if we use publicly available, free, let's say, free access data, what kind of accuracies we would receive after we simulate 184 parcels, meaning a large application. So if we achieved good accuracies, consider this being incorporated, let's say in a platform, let's say in a cloud, where it can be fed actually by all the publicly available data, and then provide the yield estimation within the season or post-harvest. So we use Sentinel-2 satellite data. Of course, we use the NDVI. We calculated the green WDRVI, and then we wanted to see the canopy cover, because Aquacrop is actually dependent on the canopy cover. It is a water-driven model. However, it requires the canopy cover, a percentage of the canopy cover throughout the growing season, in order to estimate the biomass accumulation in the crop, and then to estimate yield. We used publicly available meteorological data. We used ERA5 meteorological data. They have a spatial analysis of 12.5 kilometers, and then we received the T minimum, the minimum temperature, maximum temperature, the average temperature, and of course we estimated the evapotranspiration with the Penman-Mondith method, and then we used the precipitation, which are all required by the model. So when you may probably ask me when the ERA5 meteorological data are available. They are available they have a lag, let's say, of 5 days. So we can use them. And then we used soil grids. One part of the models that is very, let's say, demanding is to build the soil profile. So we use the soil grids, which is a publicly available soil database. It is global, of course, and its spatial analysis is 250 meters. So we use the physical soil properties for all the 184 parcels. We retrieved the soil properties by the REST API of the soil grids, and then we actually build the soil profile from the topsoil until up to a depth of 2 meters. What we calculated next was the hydraulic properties, meaning the field capacity and the permanent wilting point, and of course the saturated hydraulic conductivity using pedotransfer functions, because we had from the soil grids the physical soil properties. So these are all publicly available data. Then we plotted the NDVI from all the parcels, so you can see here the parcels, and then we actually divided them into the initial growth rate. So we have seen that there were very low growth rates and up to a very high initial growth rates of the wheat yield, of the wheat parcels. So we divided that, and then we tried to build actually the canopy cover. By using the NDVI, we estimated the green WDRVI, then we estimated the lie, And then we estimated the canopy cover. So we took representative curves of the initial canopy growth patterns, let's say, and then we used it to calibrate the aquacrop model with these 4 types of growth patterns, let's say. And here is, we did the calibration using the same aquacrop actually, and there are 2 parameters that it is very important and it is very recognized by the scientific community that they need to be changed they need to be calibrated in order to have a greater accuracy in aquacrop. So these are the CGC and CDC, which is the canopy growth coefficient and the canopy decline coefficient. So we calibrated these 2 coefficients within the aquacrop, so we used it to simulate these, let's say, teams of parcels. And we used several scenarios. So we wanted to see how much demanding in terms of data intensiveness is aquacrop and what would be the accuracies of using it one, with minimum data requirements, meaning that we relied only on literature. We took all the calibrated data from literature, on wheat, of course, for the aquacrop. We did not use any irrigation events. Yes, I will stay into irrigation events. Although wheat is cultivated rain-fed in Greece, there are some cases where water is applied if the farmer, of course, has an availability of water. Especially during 2022 and 2021, this growing season, we had a scarcity of water throughout flowering. So this demanded from farmers, some of them, of course, not all of them, meaning like 40, we had irrigation on 45 parcels. We had this data, of course, from Melissa. Melissa provided us with the parcels, with the management of the parcels in general. And then we used the first scenario with no irrigation events. We went to another scenario with no irrigation events, but with canopy cover calibration. So we calibrated the canopy cover on our own with CGC and CDC coefficients. And then we used irrigation events and, of course, canopy cover calibration. So the results were actually not so very encouraging in terms of minimum data requirements and moderate data requirements. However, in the full data requirements, we have seen that we receive, actually, because it is a water-driven model, it cannot, it takes into account rain or irrigation, and then if the rain is not enough, so it cannot achieve the aquacrop model, of course, it cannot achieve high yields. So we had yields up to, let's say, 7,000 kilos per hectare, which could not be attained, which could not be achieved by the model. However, they were very good there was a very good consistency when the full data requirements were used. So we compared our, let's say, statistical results with results from the literature, and we have seen that these results are in accordance with experiments that have been performed with under very controlled, let's say, field conditions. With laboratory analysis of the soil. So we used publicly available data and we achieved accuracies, very good accuracies, for 184 parcels under a large-scale application with soil that was with soil data that was taken from the soil grids database and with meteorological data that were taken not from a meteorological station but from the ERA5 publicly available data. So what we did next, so you can see here the RMSEs, the root mean square errors and the normalized root mean square errors, of course, are in accordance, again, are in accordance with the literature, of course, meaning literature using aquacrop on wheat. And so you can see here how the coefficient of determination is changed. We pass from 0.05 to 0.8 coefficient of determination. So then this was, these three scenarios were applied for rain-fed, both irrigated parcels. Their number was 184. So we wanted to test if we excluded the irrigated parcels. Let's say that we are in a growing season, that there is no scarcity of rain, there is enough rain during the flower period. So we used it. We did the same, we applied the same statistical criteria in order to see only for the rain-fed parcels what would be the accuracy of the model, what would be the consistency of the model. So again, we applied a minimum data requirement scenario using all the data from the literature with no canopy cover calibration, and then with the canopy cover calibration. And to our great, let's say, we did not expect it something like that. And to our great surprise, we have seen that only by using a calibrated canopy cover, we achieved accuracies the same, which were in accordance with findings in other studies. So you can see here, of course, the root mean square errors and the normalized root mean square error, and then, of course, coefficients of determination up to 0.75, which is actually found in very controlled decisions and the very controlled experiments in wheat. So, our main conclusions and outcomes are that, of course, we applied a medium data intensity model, not scenario, let's say, in a very robust and, let's say, data demanding model. However, these models with medium input data intensity can be used for yield estimation under large scales. Then, of course, we proved that the publicly available data sets are excellent sources of input for the models, of course, meaning demanding models, like Aquacrop, for example. And this, of course, these data sets can support operational platforms for dynamic yield forecasting within the season or post-season, or, of course, they can be used for seasonal forecasting. And then, that, of course, we used remote sensing to calibrate the canopy cover coefficients within Aquacrop. This can be done operationally. This can be done at near real time. Of course, Aquacrop and other crop growth models can assimilate NDVI data, F-cover data, fractional cover data. They can assimilate leaf area index. So this can be done operationally and in near real time. And then, of course, Aquacrop can be used with a high to acceptable degree of accuracy. We see medium to high consistency with measured yield data, and it can be used for large-scale and regional yield simulation. I need to say that in AgroApps we have an operational system, which is the Farm Management Information System, and we already use the Aquacrop, although we wanted to, of course, check its consistency with measured data and check its accuracies. We already use it to simulate within the season, day by day, the soil moisture in the soil. We do it exactly as I described it to you, soil moisture and yield estimation. So we do that both, and we provide it to the farmers and to the consultants and to the companies through our farm management information system, and our results are surprising up to now. Thank you very much.
Thank you, Manuel Lakakis. Are there any questions? I think the topic was very interesting, especially nowadays we had the food crisis because of the war. And I want to ask, did you start this yield forecasting before the war, or it was a result of...
No, it was before the war.
Before?
Yes. We have a long-term collaboration with Melissa. So we wanted to exploit all the data, and actually we wanted to show them and show to the people and the researchers that all the data that are provided by the companies, they return to them into improved products.
And also I saw that you use some climate change scenarios.
Yes.
Yes. So you started with the climate change as a crisis issue.
No. This is another product that we are running in AgroApps, and it is focused on the fintech sector. So we are trying to see the credibility of a farmer to receive a loan. So when a farmer, when a company, when a bank, let's say, wants to see his earnings during the loan period, then we run different scenarios, we run the aquacrop model for all his or her parcels, and then we run the scenarios and we see where his earnings will be during the loan period. So they can, let's say, do a credit scoring for the farmer, and this is where we use the scenarios for the yield estimation.
Okay, thank you. Are there any questions? No. Thank you very much.
Thank you.
So let's move to the next presentation. Is from Louis Emy. Am I right? And I think it. No. Okay. It was from Louis Emy, and it was a remote presentation. We have no connection with her or him, I don't know the gender. So let's move to the next one, which is from Radu Roska. He's from Romania, a researcher that participates in every conference that we had. And the title is Revisiting of Fire Wheel Traction Model Using a Modified Width of the Fireground Contact Area.
Kalimera, good morning. I'm from Romania. I am teaching at the University of Agricultural Sciences in Iași. And this presentation is about the simulation of wheel ground traction, tractor wheel ground traction. It is called revisiting a tire wheel traction model because it started, I think this was the older presentation, but I had some, doesn't matter. Doesn't matter. It was an updated presentation with some slides added. It started with a paper in review, and then we have developed that model. I don't want to keep you too much, but as you know, I guess wheel-soil interaction models are essentially three types: empiric, semi-empiric, and analytic. Without entering in too many details, empiric models look like this, practically trying to fit the experimental data to an equation in order to obtain the model. You see there are very strange equations, and they are particularly valuable for the respective testing conditions. The analytical models, which are more advanced, of course, because they use specialized computer programs, are more precise. They are based on elasticity and plasticity theory, but they require a lot of soil parameters, and we must calibrate the model. One of my colleagues has done something like this in a grant funded by the Romanian government, and a lot of soil parameters must be known in order to use such type of models. And you have to have a very good computer. You have to have specialized software for fluid CFD, computer fluid dynamics, and things like this. Of course, these are not available to anyone, to everyone, let's say. Semi-empiric models are simpler in the way that they use only some soil data. In our model, we use some the results from plate sinkage test and from cone penetrometer to obtain the soil data that we have used in this model. What the model predicts is the traction force and traction efficiency as given by the ASAE standard. For the traction model, as I told you, we started from a model developed earlier, which looked like this, yes, with a soil-ground contact area of an elliptical shape, in which we have considered that the smaller semi-axis of a contact ellipse was equal to the tire width. When the model was developed, some other tests were presented at a previous conference of HAICTA with different shapes of the tire cross-section. For this paper, the tire cross-section was considered to be elliptical, like this one, and the width of the tire, of the ellipse representing the tire ground contact shape, is different than the width of the tire because the tire deforms under load, and of course the semi-axis of the contact ellipse will be smaller than the width of the tire. There are some details here about, I think if I put like this, okay, yes, it's working. So I won't use this pointer anymore. Okay. We have used some geometrical considerations to obtain systems of equations, these ones, which of course cannot be solved by hand. We developed a computer program. We have here the flowchart of this computer program, but it's written in BASIC, so it's a very accessible software. Of course, just for information, solving this system of equations means somewhere between 80,000 and 140,000 steps to be repeated again and again and again until the final results are obtained, but it means like 1 or 2 minutes computing time on an ordinary computer, no graphical station, nothing very fancy. In fact, I think this was initially performed on a computer with Windows 98 initially. Okay, you see here just a part of the listing of the computer program, and as an example, the results window. This was for the geometry of the tire ground contact area. Of course, in order to obtain the traction force and the traction efficiency, we must take into account that the shearing stress at the tire soil interface depends on the wheel slip, something like this. And some authors also state that the the actual contact area between soil and the ground, the wheel and the ground, also depends on the wheel slip. You see here which would be the actually contact area for different tire dimensions and different wheel slips from a paper written by Professor Komandi from Hungary. But these results, he obtained these results for solid surfaces, for the wheel rolling on solid surfaces, not on agricultural terrain. But we have tested both variants, let's say, with a constant contact surface and with a variable contact surface depending on wheel slip. Okay, these are the formula for the traction force and traction efficiency as given by the American standard. Of course, we compared the data that we obtained with this model with some experimental data taken from the field during plowing operations. We have used a specially equipped tractor which could measure the traction force and wheel slip. Okay, and let's say, three variants were taken into account: the initial model, the upgraded model with variable contact area, shear contact area, and the upgraded model with a constant shear area. And of course, goodness of fit analysis was then developed in order to see how well the data given by our model fits the experimental data, or the experimental data fits the model. Okay. These are the results for the contact area between stationary contact area between tire and soil. As I told you, for the initial model and then the modified model taking account a variable shear area and the contact shear area, which results were then used in order to calculate the traction force and traction efficiency. And here we have the results for the traction force. The circles, the dots here, represent experimental data, and of course the lines, dotted lines and full line represent data given by the model. Of course, for the test we couldn't have too many data because as we were making tests for plowing operation, wheel slip was not allowed to exceed 30%, but we have some, let's say, 10 or 12 data for different wheel slips. And in the table below, you see the goodness of fit analysis coefficients that were considered. And the conclusion was that this model represented here in red with a red line, which considers that the shear area is constant, is the best one, fits the best with the experimental results. If we look here at the statistical indices, we see that the Pearson coefficient is just slightly lower than the initial one, from 0.92 to 0.89, but all the other coefficients are more favorable, describing a better fit between our model and the experimental data. For the traction efficiency, again we have the same chart with the points or circles representing the experimental data and the lines representing the data given by the model. And what was very surprising and encouraging was that all the data referring to the goodness of fit here in the right column of the table were much better than the initial ones, which are here, which was very satisfactory to us, indicating that probably this model with a constant shear area would be the best one until now. Okay, I shall not repeat the conclusions because I just passed through them while presenting the results. Oh, here's the references section slide, and okay. And I hope you are not like this right now. Thank you for staying with me.
Thank you very much. Are there any questions? No.
Okay.
Thank you very much.
Thank you again.
Let's move to the next presentation, which is the previous one. They informed me that Mr. Louis Emy is now connected. It's okay? The title is The Digital Representation of Smart Agricultural Environments for Robot Navigation. Good morning, Mr. Emy.
Yes. Put my presentation. Are you able to see my presentation? Okay.
Yes, okay. You can start.
Thank you very much. Good morning. As the chairman said, my name is Louis Emy, and I am going to present the work entitled Digital Representation of Smart Agricultural Environment for Robot Navigation, developed by Rebecca Parra, Pablo González de Santos, and myself. The presentation consists of a short introduction and context, where we present in general lines the project where this work has been developed, to move into the methodology presented, including a brief description of the smart data model of fireware, and to quickly finish a discussion on future. I would like to quickly introduce the problem by presenting a typical image that we present in robotic systems for agriculture, or in agriculture, in precision agriculture, where we present it as a cycle of collection, analysis, planning, and application. For us, as developers of strategies and autonomous solutions oriented towards agriculture, it has always been a challenge to carry out this interconnectivity between the physical elements and solutions that already exist that allow visualization, data processing, analysis, and definition of treatment. Thinking always in automatic, scalable, and interoperable way. Of course, there are some solutions, both operative and commercial, that help the farmer to perform farm management tasks. But what we have found is that these solutions fail when incorporating robotic systems, or more specifically, are failing in our case study. And of course, this is normal. It's a challenge to manage a large volume of data to be processed, and especially if a robotic solution is a physical system that intrinsically functions as a digital way. But also there is a large dependency on the use of standard communication systems and definition of common data models. And there are scarce development of specialized software, and every commercial or under development robotic solution have their own management software. So the project that has been able to make this work is a Laser project. It's entitled Sustainable Weed Management in Agriculture with Laser-Based Autonomous Tools. It's a project framed under the Horizon 2020 program that focuses on merging current technologies based on high-power laser source that where the weeds are being identified by the perception system, and then lasers being targeted into the meristem, is a sensitive part of the weed. All this system is carried out, that you can see on the robotic platform, and all the robotic system is being controlled and managed to a smart navigation manager, the part of the project that the research team is developing. So the main challenge in this project is to enable navigation of the full robotic system on the farm. Like starting with when the robot is being stored in a warehouse, for example, and use all of the elements on the farm in order to go to a field to make the treatment and then come back. So the main issue is how we can represent the this working environment through the use of standard data models and open access tools. And in this case, enters FIWARE, which is a curated framework of open source platform components to accelerate the development of smart solutions. And FIWARE was born as a European project several years ago and drives the definition and open source implementation of key open standards that enable the development of portable interoperable smart solutions. So basically, FIWARE gives some tools to the developers in order to build the solution, starting from the conversion of physical element to a digital element, to manage all of this data, and to give some tools in order to interconnect with third-party development. One of the main principal domains of the FIWARE is the smart agri-food sector, but there are also another domains that are important in order to develop. For example, on the case of the smart data model, one of the parts that we use for FIWARE is to describe all these physical elements on the field, on the farm. And these smart data models are built on entities that are called entities, and each entity has a specific attribute that have some information that has been described as a metadata. Within the agri-food sector domain, there are two principal elements that describe the working environment, which is called agri-farm, which is a generic farm made of building and parcels that actually are fields, and the agri-parcel, which is actually a generic parcel of land. There are another entities like agri-crop and agri-soil that describe basically these two elements. As the farm is made up of building and parcels, the building is another entity, a description, but this is another domain with a smart city. But we identify that we require a little more in order to enable robotic solutions to work fully autonomous and safety. So we propose to add another entities like a restricted area and what. For example, on the agri-parcel entity that is already being described in that way in FIWARE, they set up a set of attributes that describe the crop status. It has a crop, this is another entity, and then the location of the parcel, the field, where in a georeference element. But in order to enable robotic solutions, we need to add elements to update, like adding the orientation of the field, the headland width, and a gate location. We need to give this information to the and knows where to enter, in which orientation, and how much space is have. Also, inter-row distance is important to plan ahead all the path that the robot should follow on the field. And some information is available, like the position of the rows, or the distribution of the width, which is essential for the robot in order to have a better performance. On the same way of the agri-farm, they have some properties, some attributes that describe the farm, but we propose to add these restricted areas and raw data helpful for the robot in order to. So at the end, we build the description of the working environment as a FIWARE smart data models entities, and how we can build them, how we can create them. So one, we can use open access tool like GeoJSON that helps draw these elements in a farm. This is an example. Laboratory with experimental restricted area when we don't want the robot to enter. Some buildings in black, and then the rod in purple. And on the right, the fields. And this is useful for the robot because it can use it as a topological map in order which elements he needs to transit in and which are the interconnection between the elements. Helpful to navigate and to go from one place to another. So this tool here, JSON, as an open access tool, can help to add new attributes that other tools are able to do, but this is a tool. And at the end, we can use different tools that these maps can come from different sources. And then we build this relation map building, and the output is these messages that can enter into the spyware ecosystem. So we have this static data that has been built drawing the maps, and or dynamic data that are some parameters attribute that need to be added in another way. So we push all of this information and we create these entities that have been sent to the spyware ecosystem. So to finish, the development of a smart data model within the WILASER project offers us opportunity to provide new archetypes that have not yet been studied in the field of smart agri-food. And this methodology presented is scalable, adaptable, interoperable, and support data from other mapping applications such as QGIS, Geoman, or OpenStreetMap. And for future work, we would like to create a digital twin instance of these entities and put it on a 3D robotic simulator to continue to developing new data models not defined in fireware, like description of the robot and tasks, and to improve the API developed to be distributed in an open license. And this is all I had to say. Thank you very much for your attention.
Thank you very much for your very interesting presentation. Are there any questions from the audience? No? Thank you, Mr. Emi.
Thank you very much.
Let's move to the next one because we are out of time. I think this is the last one from Mr. Ioannis Moschos. The title of the presentation is a suitable controller for frequency control of solar thermal biodiesel biomass microhydro generation of a remote community of farm with energy storage.
Hello and good morning, ladies and gentlemen. My name is Ioannis Moschos and I am a PhD candidate at the University of Western Macedonia. I will present you our work titled A Suitable Controller for Frequency Control of Solar Thermal Biodiesel Biomass Microhydro Generation of a Remote Community or Farm with Energy Storage. The principal aim of our work is the introduction of a ponded scheme, which could be a model of a community or farm, which minimizes its waste via bioenergy and effectively synchronize the generation and demand while minimizing the frequency deviation of the system. Our main contributions can be summarized as follows. Firstly, we apply a fractional order proportional derivative controller with filter in series with a 1 plus fractional order proportional identical controller in an isolated farm or community with various bioenergy units, renewable sources, and energy storage. Secondly, we utilize the code optimization algorithm for tuning the parameters of the controllers. Thirdly, we compare the proposed controller with various controllers reported in the literature. Next, we conduct a performance analysis with the presence or absence of solar and wind power availability. And lastly, we test the isolated system in various real-world scenarios. The isolated model for a community or farm is shown on the figure. The transfer function of the system in block diagram configuration. The system consists of 3 sustainable units, a biodiesel energy generator, a microhydro turbo generator, and a biomass fuel combined heated power unit. In addition, we have 2 renewable energy sources, a wind turbine generator, and an organic Rankine cycle solar thermal power plant. In addition, we have also included 2 energy storage systems, a battery unit, and a fuel cell unit. Now, regarding the optimization algorithm, the good optimization algorithm is a swan-based metaheuristic algorithm based on the behavior of coots swarm on water. The coots are small water birds of the rail family. In summary, the algorithm imitates the procedure followed by the coots in order to find nourishment. The coots have 4 different movements on the water surface. The first movement is the random movement of coots, as can be seen in equation 1, where Q is a random position in the search space. The second movement is a chain movement, where is the average movement of 2 coots. The third movement is adjusting the position based on the group leaders. And the last movement is leading the group by the leaders towards the optimal area, which can be mathematically represented by equation 4. It should be noted that in order to maintain the random nature of the algorithm, the movements are considered randomly. The transfer function of the proposed controller is shown on the figure. As I said earlier, is a fractional order proportional derivative controller with filter in series with 1 plus fractional order proportional integral controller. In addition, the proposed controller is compared with its integer counterpart, meaning that m and lambda on the figure are set to 1, and the classic PID controller with filter. Now, regarding the simulations, the controller parameters are optimized with 10% step load perturbation. The good optimization algorithm has been set as having the maximum number of filtrations equal to 50, and the total number of coots, again, equal to 50. The chosen objective function to optimize the parameters is the ETA performance index. Now for the results, we have considered 2 main case studies, and each case study has 4 sub-cases. The first case study is the frequency response with no solar and wind availability. Case 1A is the base case, where all sustainable units participate in generation. In cases 1B, 1C, and 1D, one unit doesn't participate in the generation of power. This could be due to lack of fuel, maintenance, or a fault in the turbine generator. In case study 1B, the biomass fuel combined heated power unit is offline. In case 1C, the micro-hydro turbine generator is offline. And finally, in the last case 1D, the biodiesel generator is offline. Now, for the transient response of the 4 cases is shown on the left in figures A, B, C, and D. The proposed controller is the curve with orange color. And the transient response characteristics for each case are shown on the table on the right. By closely examining the 4 figures and the table, we can conclude that the proposed controller attains a better overshoot, undershoot settling time among the 3 controllers in all operating conditions. Now, for the second case study, we have the frequency response of the isolated system with solar and wind availability. Again, the test that we have considered are again the same as in the case study 1, meaning that case study 2A is the basic case, and cases 2B, 2C, and 2D are the cases where one unit is offline. Again, the transient response of the isolated system are shown on figures A, B, C, and D for each case. And the results are summarized on the table in the right. Again, by looking the response in the four scenarios on the left, and the trial response characteristics of the four cases on the right, we can conclude again that the proposed controller attains a better performance than the proposed controllers, while almost in all cases having better value in the objective function. And concluding, the proposed controller exhibits better trial response than its integer counterpart, and the PID controller with filter in the case of no solar and wind energy availability. The same applies and when we have solar and wind availability. And the proposed controller among the test controllers outperform the integer order controller and the PID controller with filter in all operating conditions. Finally, we can conclude that the proposed controller, coupled with bioenergy units, energy storage, and renewable energy sources, form a model of a community or farm which minimizes its waste via bioenergy and effectively synchronizes generation and demand of the system. Thank you all for your attention.
We want to thank Mr. Ioannis Moskos for his presentation. Are there any questions? No? So let's move to the coffee break. We'll have about 15 minutes, and let's get back at 11 o'clock here for our keynote speaker. Thank you.
It's a great pleasure and honor to have with us this morning Professor Mariska van der Voort from the University of Wageningen. Good morning, Mariska from Greece.
Good morning.
Let me make a brief introduction of our keynote speaker. Dr. Mariska van der Voort is an assistant professor in the field of data-driven economic decision-making in the livestock production chain at the Business Economics Group at the Wageningen University, the Netherlands. She holds a degree in animal sciences from Wageningen University and a PhD in applied biological sciences from Ghent University, Belgium. Today, she will talk about smart dairy farming, applications, challenges, and future prospects. Dear Mariska, the floor is yours.
Thank you. Thank you so much for this introduction, and good morning, everyone from the Netherlands. And first of all, I'd like to thank the organizers to invite me to give a presentation on this topic. And as you already heard, in my research, I'm looking more at the added value of data-driven application in livestock production of farms. And we look at the added value for farms, but also look at other actors along the livestock production chain. But that is actually not that much what I will be talking in this presentation today. What I will do, we will look at the smart dairy farming. We were going to highlight some of the applications that are there, their successes, and but also their challenges, and to look at some further new application developments that I see in the smart dairy farming. Before I want to dive into detail on that, I want to set up a little bit about the definition, because I think that is important also to understand the way I'm talking about sensors and technologies in my work. So when we look at smart farming, it finds its origin in precision agriculture, which refers to the technologies that make farmers less dependent on human labor, support them in the daily management, but also help them to improve their farm profitability. I think most of them also know that. However, these technologies are more an equipment that only solely automates the laborious processes. It also finds its elements back in precision livestock farming. And then we talk about the monitoring of physical parameters related to health, to fertility of an individual animal, in this case, a cow, but also to the automatic detection of an event. Think, for example, about a disease. Where satellites are the keys in the development of precision agriculture, the electronic identification system, that was the key in the development of precision livestock farming. And this allowed farmers to identify an individual animal, in this case, a cow, in a herd. So the basic elements in smart farming is that we make smart use of a technology, of the data sources that we retrieve from that technology or retrieve from other sources, and make smart decisions with that. So smart farming in first instance focusing on the management of an individual animal, and that's also what you see often that I refer to in my presentation. But of course, smart farming, and we know that it's broader than managing the individual animal, it's also managing the whole herd or even the whole farm, broader than only the animals. So if we look at the development of sensor technologies, the first development was around the 70s. And in the 70s, especially KU Leuven, we see a lot of precision livestock farming technologies and the terms coming up. Nowadays, we can use all kinds of different sensors to monitor at all kinds of different levels the individual cow. And that's also actually what you see here on the slide. So different sensors are used, and in some cases also similar sensors are used for similar types of or different types of diseases. So for example, we have activity meters. They are used in relation to mobility of the cow, but these activity meters can also be used to measure feed intake and cow fertility. So that's also what we see. Over the years, many different technologies have been implemented on the dairy farm. And the development of these sensors are often driven by the cheaper availabilities of these technologies, but also the demand from the market to come with solutions to improve animal health and improve animal welfare. And the development of these technologies are used. And that is also what we see here, for example, in this slide. This is a study of 2015. This is a Dutch study where we see a variety of technology used in automatic milking systems, but also in conventional milking systems. So if we look at automatic milking systems, we see that electronic connectivity sensors, we find them mainly back. And this has to do with the legislation that was introduced when introducing automatic milking system that forced the automatic detection of abnormal milk. And mostly that is caused by clinical mastitis. If we look at conventional milking systems, we see that activity meters or pedometers are often implemented. And this has mainly been used in relation to estrus detection or lame detection, which is, because of the bigger herd size, much more challenging to detect by the farmer itself. So that's why we see these types of sensor technologies often used in conventional milking systems. One of the most widely adopted systems that we find back in smart or in dairy farming is related to fertility, and that is the automatic detection of estrus. So detecting a cow in estrus that can be done by observing a sign of estrus behavior. So for example, the willingness to stand of a cow. And based on that behavior of the cow, the farmer decides to inseminate the cow. Achieving an efficient estrus detection requires experience of the farmer, but also a lot of attention and a lot of time. And what we see that observing estrus has become much more challenging because of the larger herd size, but also because we often make more use of unskilled labor. Besides that, also the yield of cows has increased, and this higher yielding cows tends to have also a lower intensity and shorter duration of estrus, which makes with that also the visual detection of estrus behavior much more difficult. But what makes automatic estrus detection then become so much or so most widely adopted system if we look at dairy farming? Well, first of all, a lot of different options, sensors are available. There's a lot of things to choose from. So you can measure estrus detection with activity meters, like a pedometer and a sesquilometer, but they can also be attached to different parts of the cow. We can attach them to the leg, to the collar, to the ears. Another success that we see in estrus detection is that we can link the detection of a cow with a certain behavior, so we get an alert from the system, to a very clear management action, and that is to inseminate the cow. And for sensor technology, that is immensely important, that it is very clear what a sensor is doing, but then especially what action follows up on such an alert. And an alert without knowing what the appropriate management action should be is much less attractive for a farmer to implement. A third success factors that we see is that the performances of these detection systems are quite good. So several studies shows improvement from a 50% detection rate up onto an 80% detection rate. So often we see that these systems are doing a much better job than the farmer can do in practice. Another important success factor is that it reduces labor. So we see farmers are interested in that because they don't have to go into the stable anymore, spend a lot of time observing the behavior of the cows. And at last, and an important one, is that the investment in the sensor seems to be very economically beneficial. So the cost efficiency of an investment, we have seen that back in several studies, is a clear indication of a success factor of a sensor technology. So these are important success for adoption. But in practice, we also see that these technologies are facing challenges which hamper the adoption on the dairy farm. And in the following slides, I want to dive a little bit more in these challenges. Some are related specifically to a disease, and other are more general challenges that we are facing. So one of the challenges that we see in developing a system which has a performance which is good enough, so it's actually also predicted that something is wrong. So the thing that we are looking at is often something that is looking for something that's a needle in a haystack. So we are looking for something that is not often happening on the farm. So say, for example, mastitis. That's an inflammation of the udder, which is painful, or which can be very painful for an animal, and also reduces the milk quality and production. Mastitis is one of the most costly diseases, production diseases in dairy farming. The challenge with mastitis is that only 0.04% of the milkings has a sign for mastitis. So say, for example, every milking is a test. You have about 2.6 milkings a day. Say you have a herd of 60 cows, it means that you have 57,000 milkings per year. From these 57,000 milking, only 20 milkings is a mastitis case. So with an average sensitivity of 50% and specificity of 95% of these detection systems, a lot of cases are missed, but also a lot of false alerts are generated. And with that, the success is very low of these systems to really find the true mastitis case. And additionally to that, we know from experience that only 3.5% of the alerts that are generated are actually checked by the farmers. So that means more cases of mastitis are missed. Another important challenge is when we generate these alerts that there is not a clear management action. And I indicated that already, that in case of estrus, there is a very clear management action. You're going to inseminate or not. However, for many of these diseases, like for mastitis, it's not a black and white decision. Mastitis, you have roughly two types version of mastitis. One is visible, the clinical one, and a non-visible, a subclinical one. So this last one, you cannot see or feel, you can only measure it. So also knowing that most alerts are seen as being wrong, these subclinical mastitis cases stays unseen. For clinical mastitis, there is then also a very clear treatment. But in case of subclinical mastitis, it is not. Because when subclinical mastitis is detection, the question is still, are we going to treat it or are we not going to treat it? And what kind of treatment are we going to give it? Or maybe are we going to wait for a treatment, because also in case of subclinical mastitis, a cow can cure the problem on its own. So for a farmer receiving an alert that something is wrong, the next step is to come up with a clear action. And that clear action results in a potential value. Besides that clear management action which is needed, we also see that often these systems are not ready in use. So for example, that we see in lameness detection. And questions that we see in lameness detection, we can measure all kinds of things. So for example, here in the picture, you see a camera analysis from a cow. These can be used to detect that there is an abnormal behavior, in this case, an abnormal locomotion. So we see something is going on, but we cannot link it exactly to a clear action what to do. So what is really the useful information and the action that is required upon the detection of lameness? Well, I put them into one slide because these are quite closely related. Systems that are not ready in use because we don't know what to monitor, and the next step, okay, what is the action to take? The last challenge that I like to highlight here is that the fact that we do not have enough insights in the cost and benefits of the sensor system. And we know from previous research is that knowing something about the economic performance of the sensor system is important in the adoption on the farm. Often we know very well what the cost is of a new sensor technology. So we know what the investment costs, but what the real benefits are, those stays unclear. So although sensor technologies often claim that they improve the economic performances of the farm, there are indications that actually the costs are unexpectedly also can increase. And then I'm not talking about the investment cost, but I'm talking, for example, about the cost of labor. So what we often see happening is that labor is increasing. So for example, due to checking false alerts. But more importantly, an early detection of a disease could also result in more treatment than previously has been done. We detect a disease early and therefore also we treat an animal earlier. And at last, we see that when a sensor system needs to be implemented, also a change in management is often required. And we know from experience that when management is not changing, it does not result in higher balancing. The challenges that I now highlighted, they're very much from the perspective of adoption. And of course, when we're going to look at the technical sides of the smart farming technology, the development of the technologies, much more challenges can be found, but that's not something that I wanted to highlight today in this presentation. If we look at the development of sensor system in the dairy sector, the main progress has been taken place on here the level 1 and the level 2 of development. So we see that a lot of development took place around the sensor, so the technique and the detection algorithm. In dairy farming, what we have seen often is that technique development, data interpretation, that's actually where it stops. So a further development into integrating it with other sources of information, with decision making, that is something we hardly see. And that is also here presented in this figure, which is a study which is relatively old because it's from 2014. But here you clearly see the number of publications for certain diseases in dairy farming where the development relation to sensor systems has been taking place. So here, take, for example, mastitis. A lot of work has been done on validating the algorithm. In fertility, we see also a lot is done about validating the algorithm and also finding the relation between sensor data and the gold standard. But if we then have a look at metabolic diseases, hardly any papers are found. So the main problem in case of metabolic diseases is that we are still looking for the right parameter to find that says something that there is a metabolic or there is actually a problem. So we see most sensors do not reach that step 3, that step 4. So coming to a decision support model, combining it with other sources of information and really lead to a decision-making tool. Of course, in the meantime, things have been changed. Sensors have been further developed, have been improved, have been tested, but still that final decision support is an obstacle to overcome. So what do we see actually? So what do we see in the latest development in relation to that smart dairy farming? Well, I first want to have a look at that technical development, and then next I take a step to that decision support, where we already have seen that not a lot of development has been taking place. So looking at new technology, we see a lot of work in relation to finding biomarkers. So finding biomarkers for stress-related issues and metabolic disorders, and try to use these biomarkers in early warning systems. Another direction we see a lot of happening is in relation to activity-based welfare assessment. So where activity data, which is collected in relation to other events. So for example, estrus detection and lameness detection is now we look also if we can use that activity data to say something about animal welfare, about the animal behavior. Another direction where we see work happening is in relation to the use of temperature and pH sensor and use those data for detecting some other events. So for example, so for example, for detection of calving alerts or for rumen functioning, rumen health. So we see also temperature pH data used for generating other detection models. And that is especially what I have seen the last couple of weeks on other conferences that I was. There is a lot of work going on around video-based analysis about 3D visions, about facial recognition. So for example, for body condition scoring, detection of lameness, but also the abnormal behavior. A challenge in these video 3D vision systems, there are actually two challenges. First of all, making a link between the parameter that we analyze and the abnormal event, but also making these systems work in practice. So having these implemented on a farm, but making them also workable. So we looked specifically now at the sensor techniques and its developments, but smart farming, dairy farming is more than only the sensor techniques. It's also about the smart use of data. And data integration is one of the biggest challenges that we are facing within the dairy industry. And that has to do because we're collecting a huge number of data from different technology. And what we see is that it results in a data overflow at the farm. So the daily management of an individual cow is a task which consists out of all kind of separate decisions and operational structures. So think about the feeding, about milk production, about the economics. And this is also what we see then back in the data stream. They are generated on the farm, like the milking, the feeding, and they make often use then in that collection and analyzing and visualizing on separate software system. And as such, the results and also the decisions are very isolated. So on several levels in the dairy farm, we nowadays find projects where they working on integrating these different data sources. So for example, we see that back in precision breeding, but also in smart feeding and in general evaluating the livestock behavior. That integration of data has been proven to be improve actually the prediction performances of our algorithms. So compared to using an algorithm with only one data source, combining data sources improve the performances. But we also see an improve in data quality by combining data sources and a more efficient use actually of the data that we have. So linked to that, linked to the collection, the integration, management and analyzing of all that data that we collect on the farm, but we also have data that we collect off the farm, has been gaining much more interest in the agriculture sector in general. So not only actually the dairy sector. And a nice example I like to highlight there is the development of digital twinning. So a digital twin is a dynamic model which actually observing a physical object, which emphasizes mainly on connecting between the physical object and its model, but is also using real-time data from that physical object to keep a model synchronized with the real situation. So a digital twin is nothing more than a digital copy of a physical object of the real world. So that could be a cow, that could be a whole farm, and we see that often more on the technical side. So for example, think about a windmill. This digital twin development could potentially provide a solution for better data integration, communication, and synergy actually between models. And it Another advantage of digital twinning could be that it can allow us for experimenting with, for example, new management solution without exploring it, or actually without exploring the effects on the real farm, but trying that or exploring first that on a digital level. And that makes this type of digital twin very much of interest. And we see in relation to dairy farming, smart dairy farming, we see this development on different universities. So for example, you have the dairy brain, that's from the University of Wisconsin, and a digital twin, farm of the future, is developed at Wageningen University and research. And I think there is a lot of potential in this digital twinning to come to better explore, use the data, and make smarter decisions in dairy farming. Another trend that we see in dairy farming is collaboration between companies. So traditionally, farm advisors, suppliers, breeding companies were working individually. Nowadays, what we see is a more integrated level of collaboration, sharing data, sharing market partnerships. So for example, you see companies are buying other companies. So Zoetis, for example, bought the Australian eartech startup company SmartBow, but we also see that, for example, the Laval bought data dairy warehouse company. So that's actually a data company. But we see also partnerships, for example, Bayer, John Deere, the Laval, and Uniform Agri. These collaborations are important because the data that is collected by one of these parties can be very useful and interest for other parties. So we see a development in different business models and new partnerships, power relationships, but also especially the value that can be generated from these data. We see that changing. And this is important for the dairy sector. It's an important change, maybe something we have seen actually in the past early already in simply the agricultural sector. Another interesting development that I want to highlight, and that we really see a shift in focus, is to use the data that we collect to use for animal welfare assessment. So PDA, or these precision farming technologies, already improve farm animal welfare by improving the detection of a health issue, a rapid treatment, so detecting the problem earlier. However, the data that is now collected could also be very much used to study the behavior of the animals and to see if we can link it to some animal welfare assessment schemes. The advantage of using such sensor data to assess animal welfare is that it could allow us to real-time monitoring the health and welfare status of a cow. Instead, something that we now do once or twice a year, we go to the farm and determine what the welfare status is on that farm. That's the general welfare status. In this way, we could also look at the individual animal welfare status. So it could provide a real-life measure of the actual situation. It makes animal welfare assessment also more objective, and we're not dependent anymore from that one specific person that is assessing the welfare status of the animal. And another advantage could be to look more at the animal welfare with these data is that the labeling systems that we currently have could become much more transparent, which could result in more consumers' trust. It can even lead to maybe more fair premium prices that are related to the labeled products relation to animal welfare. And in relation to that animal welfare, a specific question that gained our interest in our group is that, okay, if we measure animal welfare and we have the sensor system implemented, what is then actually the economic value of such a system? And then for who is that value? Because if we think about who needs to receive value from a sensor system, I rationally put the farmer up front, because the farmer is the one that implements the system, so also need to gain benefit. However, when we improve animal welfare, which is pushed by the consumer market, we are a little bit more skeptical about it. Is it really the farmer who can benefit from that system? And well, if the farmer can benefit, what is then the minimal requirement of such system? And that is very much of interest in the research that we are currently doing. And we also see that from adopting sensor systems that economics plays a role. So you would think that if we dive into literature, a lot of economic proof is present. However, that is not the case. So if we do a quick search on the Web of Knowledge, we see about 63 publications related to PLF and mention something about economics. From these 63 present papers, only 19 papers also present an economic figure. And from these 19 papers, only a handful of publication is really assessing the economic performance. And the challenge in evaluating the economic performance of a sensor system is that they are often not implemented on a farm, or there are not enough farms to perform a proper economic analysis. So therefore, we advocate actually to perform during the development of a sensor system an ex-ante analysis, for example, with a bioeconomic simulation model. And these forms of modeling could allow us to study the possible effects up front. It could allow us also to study what are actually then the minimal requirements of a system before it becomes of economic interest. And something that we now also do, we integrate it with the welfare gain. So if we have such a system, what is maybe the trade-off between the economics gain and the welfare gain? So we really advocate to look at, during the development of these systems, also what should be the minimal requirements in relation to economics, in relation to animal welfare, and we could even think of other factors to include, for example, the environmental impact of a system. So there's a lot of going on in smart dairy farming, much more than I told about in this presentation. But we see that the main focus on smart dairy farming lies on the early detection of production diseases. And we also see that the detection systems are at the moment still far from perfect. Science is looking for different ways to improve it. That's about combining data, that's about improving algorithms, but also on the technical side, improving the sensor, the technology itself. And we see that, for example, video analysis, image analysis. An important direction that we see research is going to is that data integration, and I think digital twin is a nice new movement where not only data is integrated, but also modeling approaches can be integrated. And then at last, as I mentioned earlier, I advocate that we should do more often upfront research when we are developing a new detection system on what are the minimal requirements from an economic perspective, from an animal welfare perspective, and maybe also in the future also looking at the environmental performances of these systems. With that, I come to the end of my presentations. I'd like to thank you for your attention, and well, if there are any questions, I'm happy to answer them.
Thank you very much, Mariska, for this interesting presentation. Indeed, you have commented on many critical issues the research community are working on. So we are ready to accept questions from the audience. Are there any questions? Yes? Just a moment for the microphone.
Hello, my name is Renaitis Kyriakos, and I come from the Agricultural Economics and Consumer Behavior Lab of University of Thessaly. I was really glad that during your speech you were referred to the minimum economic requirements of the system, meaning that you have taken into consideration the economic aspect. But I want to stand on another point. You have been referred several times on adoption from farmers, which is, I think, although we have a lot of technology and sensors being applied, the adoption still remains in very low levels. Have you done any field trials making changes in the final software for gaining more insights on what works in the farmers or what doesn't work on them?
Yeah, we currently are actually doing that. So I'm involved in one of the digital twin projects, and what we do in that project is that we are collaborating closely with farmers to really assess what their needs are. So where do they have the questions, and when they work with the systems, does it give them what they need? So we're really trying to adjust the system to what works for the mainstream of the farmers. And I think that is very important for the implementation, also for the sensor systems and the software behind it, that it's not just delivering indeed at farm level, but that there is also an education platform at the moment when it is developed, that the farmer also learns to work with it. So I think it has two sides: collaborated developing such a system, and then also providing enough support. And it's interesting because yesterday I had a meeting with an arable farming, and that arable farmer is quite good with data and with analyzing figures and so on. And what he mentioned is what is very important for a system is that, yes, it gives me an alert. Yes, it indicates that something is wrong, but it should also be able me to explain what is wrong and why it is wrong. So he clearly indicated that he needs more information. And then the next step is, when it's indicated what is wrong and why it's wrong, is to provide with possible solutions to solve the problem.
Thank you very much.
Okay,
You're
thank
welcome.
you very much.
Thank you for your question.
Okay, and I want to ask you also, we know that the consumers day by day are being more environmentally friendly and aware about environmental protection activities, even during the production process of agricultural goods. To what extent these technologies can meet the consumers' awareness, taking into consideration that especially dairy farming is on the epicenter of criticism regarding environmental pollution and environmental degradation?
I think there is potential in these systems to create transparency. And partly we are already doing that in livestock production with using these different types of labels, saying something about welfare, about fair trade, about that it was grown in a sustainable environment, and so on. But of course, with these labels, I think consumers still cannot really see what is going on. So I think with having this collection of a lot of different data on different levels, we could integrate that in a system which creates transparency. So maybe think about going to the supermarket and have a QR code and know exactly what the performance, environmental performance is of the farm. So yeah, the potential, I think, is creating openness of what is going on. And I think especially, and that's completely right, the dairy farmers are criticized a lot especially at this moment in the Netherlands. So for farmers, it will become very important to have a license to produce. So not only having produce economically sustainable, but having consumers accepting them to produce on a certain way.
Okay, thank you very much. It was a great
Thank you.
pleasure having you here with us digitally, hoping next time to meet in
Yeah.
person. Okay.
Yes, thank you very much, and enjoy the rest of the conference.
Okay, thank you very much.
Thank
Have
you.
a nice day. Bye-bye.
Bye.
So we are proceeding to the next session. Yanni, it's your time.
Good morning from me. My name is Ioannis Fotidis, and I will be the head of the session 3. Since we are a little bit behind in time, I would like immediately to call Mrs. Malamuti Luta, I hope I'm saying the name properly, in order to give a presentation of her work titled Intelligent Pesticide and Irrigation Management in Precision Agriculture, the Case of Vilos Project. You have the floor.
Hello, my name is Joanna Karabellia, not Malamatiluta. I'm the presenter, not the writer. Okay. Well, I'm a PhD candidate student of the University of West Macedonia of the Department of Electrician and Computer Engineering, and I'm going to present you our work entitled Intelligent Pesticide and Irrigation Management in Precision Agriculture, the Case of Vilos Project. The integration of novel information and communication technologies in the primary sector enables data collection and analysis concerning critical parameters of the production process. Furthermore, predictive mechanisms exploiting artificial intelligence, AI, and machine learning, ML, techniques led to the generation of new knowledge and support informed decision-making, contributing to increased production quality and quantity, profit maximization, cost reduction, and overall environmental footprint minimization. In the precision agriculture domain, minimizing pesticides usage and optimizing irrigation application has profound positive outcomes to crop yields and both farmers and environments in many ways. Now I'm going to present you our proposed ecosystem called Vilos, which is a smart ecosystem for pest management and irrigation of bean farms in the Prespa region. This Vilos consists of multiple subsystems, like wireless sensors, an automated UAV or drone fleet management system, and unmanned ground vehicle, a data platform, prediction classification models, thresholds and risk indicators, a smart decision-making system, and finally the traceability system of the final product. In this slide, you can see our proposed architecture. The letters is so small, but in the next slides, I will describe you in more detail each subsystem. Regarding IoT subsystem, a long-range wide area network, LoRaWAN, is considered the best option for the transmission of IoT-related collected data, for example, soil moisture, temperature, and humidity level in the Vilos ecosystem. Additionally, the Vilos ecosystem will effectively exploit the telemetric meteorological station network, which is already installed in the Prespas area. Regarding the UAV subsystem, this model supports the organization and coordination of available UAVs to achieve common goals. The UAV fleet will include UAVs belonging to one or more providers, supporting their management and coordination in order to collectively process and satisfy crop monitoring requirements in agricultural production, considering also UAVs already involved in a mission in the area of interest. The UAV subsystem includes mission initialization and definition, UAVs incitement, flight generation, and the ground control system. Regarding the UGV subsystem, Velox exploit a custom-made robotic UGV that will be constructed to enhance collecting data quality and improve pest prediction accuracy. As you can see in this picture, the UGV necessitates a solid construction which is equipped with DC motors, enabling movement in the area of interest, a robotic arm mounted with a multispectral camera, sensors for obstacle avoidance, and GPS receivers. Concerning pest risk threshold subsystem, empirical prognostic degree-day thresholds and epidemiological plant disease risk indices are developed in order to timely forecast the seasonal occurrence of the most important arthropod pests and diseases of bean. In more detail, degree-day thresholds for Helicobacter armigera, thrips, and Tetranicus urticae are being developed and further validated, as well as epidemiological growth risk indices for the fungal pathogen, which is the cause of the bean rust. At this point, I would also to add that data from the dew-crowned season 2021 and 2022 are collected and used along with demographic parameters and temperature-dependent development thresholds available from the published research. The next subsystem is pest damage disease engine subsystem, which aims to detect arthropod pest damage and plant disease symptoms based on images taken by UVs and UGVs. Machine learning algorithms have been used extensively for pest damage and disease recognition in plants, and there is a great interest in the international literature for this topic. The input of this subsystem is typically a set of images, and the machine learning algorithm is applied to categorize the depicting plant either as healthy or not, and in the latter case, determine the disease. Finally, this subsystem applies a portfolio of detection models to get the best possible result. Concerning the irrigation forecasting engine subsystem, its aim is to predict the irrigation needs of the field. In this subsystem, we use a plethora of pre-processing techniques in order to reshape and modify data. In more detail, as you can see the flowchart below, this subsystem collects IoT-related data, for example, for soil moisture, temperature, rainfall, etc., and data from external subsystem, like open meteorological data and weather forecasts from open APIs, applies a portfolio of regression machine learning techniques, and produces the final irrigation needs for the pilot fields. Finally, the Velox decision support system suggests an appropriate irrigation schedule to farmers based on the identified needs. The core of this smart ecosystem is the intelligent decision-making system. Regarding pesticide application, the proposed system includes a three-stage approach of pest prediction, which is expected to improve the system's overall prediction accuracy. As you can see the flowchart on the right, the first stage of pest prediction is degree-day thresholds and disease risk indices, and are complemented with UAV flight missions that are either pre-scheduled or triggered by the user requests. As a next step, the robotic system is activated after it is provided with the corresponding coordinates. In more detail, it obtains more images of the afflicted area, which are given as input to the PDDE subsystem and feed the models with new data that improve their predictions. Now I'm going to describe you the experimental setup. These are our meteorological stations that are already installed in the Prespa region. During each of the bean growing season, sequential observations are taken twice a week from 4 experimental bean plots. For 2022, this year, the UAV and UGV-based images are collected from the pilot fields so as to train our machine learning models for the pest disease detection engine subsystem, with additional soil moisture sensors will be installed in order to further support the irrigation forecasting engine subsystem. To sum up, the VELOS project, as I said before, aims to assess the risk of occurrence and predict infestation of bean cultivation by arthropod pests and plant diseases, as well as making pesticide usage and irrigation application scheduling recommendation for plant protection and optimization. The future work includes development of empirical thresholds and indicators for the above species and their evaluation during the current growing season for this year. These pest thresholds will also be incorporated into the pest damage detection engine subsystem for improving prediction accuracy. Thank you very much for your attention.
Thank you so much for the very nice presentation, and I hope I will get your name right now, Ioanna Karambellia.
Yes,
thank you
that's
so
right.
much. Any questions, please? Yes.
Thank you very much for the presentation. Just a small question. How easy applicable is this decision-making system in other crops?
In other crops,
Yes.
no beans.
No beans, in other crops. I mean, it's a decision-making tool, so probably in the future it's going to, I don't know if it's going to be applicable also in other other kind of crops, not only beans.
This is our main focus, yes, of course.
Yeah. And it is easy to apply in other crops like
Our
I don't know.
ecosystem, sorry, thank you for your question. Our system is very scalable and open source, and I think it's easy to scale from other farms, fields, rather than beans.
Okay, thank you very much.
Thank you.
Thank you so much. And immediately I would like to call Mrs. Evdokia Kristallidou in order to give a presentation about radio frequency energy harvesting system and the utilization of the blockchain technologies in agriculture. The floor is yours.
Thank you. And I just want to inform you that I'm going to change slightly my presentation, and I'm going to present it not as a researcher, but as a farmer. And I decided to do that because I believe that we don't have, the input of a real farmer. So let me introduce myself. I'm coming from the American Farm School, and we have American Farm School is located in Thessaloniki, and we have 120 lactating dairy cows. We have 30,000 laying hens, so produce our own omega-3 eggs. We have our poultry section, so we produce our own poultry. We have our own feeding mill. We have our fields for producing our own maize. We also have small vineyards, so we produce our own wine. And we have a small dairy plant that we produce our own meat, and we bottle our own milk, just to have an idea of what we're doing. The last years, we've decided to, let's get involved in the digital farming. We didn't have any idea, so we just bought different tools from everyone. We're just starting to collaborate, and we're just starting to using different sensors, and again, in different farms, inside our barns, and inside our fields, and in the large network we have. So we used different sensors, soil sensor, moisture sensor. We used sensors for CO2 and methane production in our farm. We use satellite images. We use drones. We use almost everything. We also have a large network of different farmers all around. This is for northern Greece. And we use, again, LoRa network, Sigfox network. We use GSM network, all the networks we can use. We test them. Right now, we have a huge LoRa network. We have something like 30, if I remember correctly, 65 gateways and 12 weather stations. This is our coverage, and we have a huge network of different cooperatives. Like I told you, we have a lot of things, and we use them. We are just the end users, nothing else. Using all these technologies, we have a lot of problems and some challenges. First of all, Interoperability of different protocols. We're using different sensors. One is using Sigfox, the other one is using LoRa, the other one is using GSM. What about the future? Can I have a sensor that can always integrate, different protocols? This is a question probably for you as a researchers. Reliability of different data. I have sensors. Imagine that I have sensors and I'm putting a sensor in the soil and there is a rat eating my cable. Or the cable went out and, for example, the temperature inside measuring, the soil, it measures, the sun just outside. The farmer doesn't see that. He only sees, an alert saying the temperature rised in 50 degrees and you have probably to, let's say, moisture and irrigate your field. Where is the wrong? Who is going to tell me and probably clean the data for me? This is another question. Some of you do that, some of you don't. This is just a challenges that we have. Really, we have to move again from just measuring and detecting from different sensors and moving it from, let's say, sensoring to decision-making. For us and for the farmer, this is the most important thing. Not just get the values. Do something with the values we get. And just to say with Matita, we don't have to just play with the sensor. It's very difficult to have a farmer and, let's say, the technological part and get them all together. You need someone to explain what do we read, what do we have to do with those data. That's why for us, probably consultancy and maybe having an agronomist in the middle is very important. You really need someone, let's say, to translate everything that the sensor is getting. Network maintenance, for us it was really, really important. Imagine that we had, a huge network, and to be honest, we didn't have anyone to support the system. Very simple things. The battery has run out. One cable went off. Something. The farmer cannot work with that, doesn't have the time to play with these things. So this is something, again, really important for us, and maybe we have to see and do something about that as well. Farmer engagement is something, again, very, very demanding for us, and of course, a self-sustainable business model for us as the American Farm School, again, is very, very important. This is the farmer's point of view, and there was a project collaborating again with the Aristotle University of Thessaloniki, the Computer Electrical Engineering Department of Aristotle University, the Physics Department, the Institute of Information Technology again in CERT, the University of Western Macedonia, and they came up, I don't know anything, with a project. They have different cases. I'm just one of them. And they promised me Edge Node, they promised me digital twin, they promised to me edge computing. So this is something we started playing together. So I'm not going to describe anything, like I said, technical. I'm not the expert. I'm just going to present what all the other team has made that for me. They promised that at the end, I'm going to have a farmer who is going to, let's say, monitor the field. And because I'm an animal nutritionist, we focused in the animal nutrition. So we saw the case of a livestock farmer who also have livestock and different fields. So our case focused on that situation. They also promised me that, we are going to have at the end a very easy platform to handle. And also we're going to have AR glasses, and we are going to have, all the information on the glasses of that farmer. This is something I'm going to show you at the end. At the moment, the Aristotle University started playing with how can I always try to find and, let's say, use different sensors, not with battery, with an alternative way. So they came up with, this is something well known, they told me, but we are going to test it again in our fields, in our animals. So they're using radio frequency energy harvesting. This is something that is becoming increasingly interesting in the last years. And they told me it's a well-promising technique to deliver power in systems that require small amounts of energy to operate. So they suggest to me that probably this is a solution. I'm just giving you the details that the guys sent to me. Forgive me about that, but I don't have, I'm not the expert to explain about the technical things. They also suggest to me that we can always use and try to have different blockchain techniques, and this is something we are going to implement later on in our project. Because for a farmer, it's not always really nice to have different sensors. Okay, we can always monitor our production, reduce our cost, consider about the different animal welfare of our animals, but we also have to sell our products. And blockchain is a solution that probably the farmer can use later on if he wants probably to enhance the quality and probably the price of the different products. So this is something they've started again to look after, and this is something they want to deliver at the end of the project. I don't have my, okay. Sorry about that. I'm just going to show you not the interface. They produced a video for me, but I'm not going to show you all the interface. I'm just going to move where we are right now. I'm not going to, I cannot see very nice. Okay.
On its premises.
This is a farm we have in Kozani, and this is my colleague Nikos Koltsidas, again in Kozani. And this is what he sees in the classes right now.
At this moment, I can check the air humidity inside the barn. I can check the conditions, also the air temperature, which is very important for if we have a quick increase in order to prevent heat stress to the animals. So we can open the windows quickly.
You can see over there what Nikos sees at the camera.
The air temperature. There are times during the day that we have this kind of quick increases of the temperature when the sun is going down. So as soon as we are getting informed from the application, we can act immediately and reduce the air temperature. Also, I can check the level of the methane.
Let's go over to the
The other thing I asked for the guys is, because we're using RFID reader to scan probably the electrical boluses we have in every animal, the next aim of the guys, this is what they promised to me, because I'm the end user, like I told you, is I want every time I can see an animal, I can always read the animal and have the information on my classes. For example, the lactation for that animal is that, or maybe I did vaccination at this animal right now. And the last thing I asked, again as a user, okay, I'm just the end user, it's just like, live streaming again video, wearing again the glasses, and talk probably with an agronomist or a veterinarian, which is away, and for example, see the mammary gland, and see, do I have to do any treatment, something is wrong with the animal, and have, constant consultancy, real-time consultancy. This is what's something I asked as well. So hopefully, by the end of the project, they are going to deliver all these guys for me. That's all. I try to do something different for you and hope it's okay. Questions?
Thank you so much. Any questions? Yes?
Question. You talk about farmers' engagement in these technologies, and do you think that their engagement is related to their age or other factors?
Okay, imagine we are working with something like 1,500 farmers right now, because we are working with different cooperatives. We're working with different operational groups as well. So we've seen that, again, the age is a huge factor. You can imagine that. But especially in the livestock, horticulture is higher, let's say, than animal scientists. I mean, the people who are dealing with the livestock production. Again, over there, we still have problems. Even, the younger people, the children of the farmer, still has, the doubts, the, second question, second thought. And we also have seen, because we also see the different, we also see women engaged in the agri-food sector, again. So again, over there, we saw differences over there. Although there are a lot of women working, again, in the livestock sector and in horticulture as well, we don't see them. But if you go to the farm, you can see that the one who's, let's say, is in charge and the one who's keeping low the data, the records, is a woman behind. You can always see that. And we've seen it almost in 80% of the farms we visited.
Yes?
Yes, hello, thank you very much. It was a very interesting and different presentation. Just as most a comment, I'm coming from the Mediterranean Agronomic Institute of Montpellier. About the challenges that you referred in the beginning about how, as the scientists, we are going to facilitate the way to eliminate the work for the data or any problem. Apart from all this, I mean, the hard science can provide the solutions and facilitate and simplify all these processes. But speaking from the socioeconomic point of view, the biggest problem is not only to invent and to facilitate something, it's to make the people adopt it. So the biggest problem that we have at the European level is the farmers' adoption process. And until in France we have many technologies, many farms that are participating in projects, but in the end nobody is adopting it.
Yeah, that is true. And this is something we try to, let's say, not solve, but we still have, small initiatives that we try to either educate, so we're using different, the social impact of the social scientists. So apart from the people, the agronomists, the technical fund, we also have social scientists back up and support us. Because really, we don't know how to approach the farmer. We don't know how to talk to the farmer. We don't know how to persuade him. And you have to always keep in mind that in order to persuade a farmer, you really need to show him that something is working. And if I'm going to use this technology, I have to make sure that, this technology is working. I don't have problems with that. I trust it. And if I trust it, at some stage, the farmer is going to trust it.
Yes, I agree. Thank you very much.
Thank you.
Thank you so much.
Thank you.
And we can move on. I would like to invite Mr. Chrysostomos Stilios, who is going to give a presentation about EUCREAS, an integrated framework for effective traceability of Greek meat. That sounds very tasty, in my opinion.
Hello, everyone. My name is Salmas Dimitrios. I'm from University of Ioannina, Laboratory of Knowledge and Intelligence Computing. And today I'm going to show you an application that we developed and framework for a project called EUCREAS for a traceability for a meat company focused on effective traceability. Our issue was that for an SME, it was really hard to find a solution that fits their needs. A tool, a small tool, based on the customer needs, not just a generic one. A tool that conforms with regional law regulation, because the past year Greece starting had a lot of law on traceability. And what the system can do with the system, they can monitor the production, they can decrease the probability of product recalling, and the system is designed for their needs. That's the most important part, because most of the SMEs have a smaller budget, of course, and they have specific needs that's having for the few animals they are having. So for the development of the system, as a methodology, we use Agile, Scrum, just it is there to show it to you. On the practical now application of the system, the images are a bit small. So we're collecting and recording data from the farm, the factory. As soon as it leaves the factory, processing, packaging, and other things they're doing, and up to the point that they're sending to the market. Our system is separated to a cloud server. Therefore, we have a backend, a database. Database is MongoDB, and we focused on a REST API. Why? Because our system should be flexible. We're creating application for the end user. The end user can be the employee of the office, the employee of the farm, the employee of the factory. Everyone can use it. That means we're using mobile application, desktop. We're using a tablet in some cases. So we went to web technologies for this part to have as many users as possible. So some screenshots from the applications. As you can see, we have a lot of big buttons. This is because the application can be used from the tablets, and the tablets are having, and the users on the factory are having big gloves. It's hard to press small buttons. Inside, the company can search to find animals based on their code, because it's unique. They can find some filter information they can use. With one glance can see everything about the animal. It's really important, especially on the traceability, to find information fast and easy. In case of recalling, because let's be honest, it happens. Not often, but it happens. The company only needs to add either the product that had the issue or the animal. Based on this, the system searches everything for everything. It finds all the byproducts of the animal, all the animals that may have been on this product, because if a company makes a sausage, may have 4 or 5 animals in there. So they don't know which animal was it if it was a product that was recalled. Therefore, they have every information that they want to, and especially at which shop it went. It's really important for them to recall it fast. We have some statistics for the company, because they need to see what they're going into the farm. This statistic includes something simple like how many animals they have from a specific race, how many animals they have of specific sex, how many animals died from diseases, or how many animals have specific diseases. Not that common, actually. And here is a small image of the application. I'm showing to you right now details of a product. The company can see the name of the product, for which shop it went, where it went. If it is just a piece of meat, they only see the shop. If it is a byproduct like sausage or anything else that gains some spices in there, we see the whole mixture, everything in there, the whole recipe. So we evaluated our system by stress testing it. Since the company is using it, and we need to know if the system is reliable, we went to some crazy scenarios. For example, in this scenario, we have, if I can see correctly, 150 users concurrently sending instant information to our biggest query that is getting every single data from all the animals. As you can see here, we have the response is below half second, and it's quite good because they're not gonna having 150 people, maybe 10, but still we had to test it. And then we went to a situation where we escalate the system slowly, something like 5 people, 10, 15, up to 30 people at the same time, same second. We're talking about a total of 2,000 requests within a minute. It's a lot for this kind of system. That's 400 milliseconds. But it's actually quite good, at least for our situation. And the final one is we added 10 users. That is a little bit close to our situation for 30 seconds. Less requests. This is again below half a second. It's really fast, reliable. So, conclusion about our system. It helped the company, providing a lot of traceability applications, especially with the recall. It's really fast and helpful for them. It's a methodology that I just presented you as my methodology. The solution is very adaptable. It can be used to other companies by making very small changes because they may have a different data or something extra they need to monitor. And thank you for your attention.
Thank you so much. Any questions? I don't see anybody. Thank you again, and we will move immediately to the next presentation. I would like to ask Mr. Radu Roska to join us, yes. And as I can see, you have 2 consecutive presentations. And the first one will be a coupled electromagnetic and heat transfer model for grain seeds drying in a hybrid dryer.
Hello again. In fact, it will be a very short presentation for both papers because I'm not the main author. I'm just presenting for the main author who couldn't be here. And in my opinion, the logical order should be reversed between the 2 papers. In fact, what's everything about? It's about designing a new type of dryer for seeds based on microwave drying of the seeds. Instead of the classical method of drying the seeds with hot air, my colleague is trying to reduce the energy consumption by using microwave drying. And this part, which is presented in these 2 papers, is, let's say, the theoretical part, the modeling part, which was then applied to make the physical dryer. There are 2 papers because one of them deals with the motion of air and the seeds in the dryer, and the second paper deals with the heat transfer between the seeds and the air used to propel the seeds. For the first part, this is the modeling of the motion of the seeds and dryer. The CFD and DM computer fluid dynamics and discrete element methods were used for simulating the motion of air and seeds using some specialized software like Fluent and EDIM. And for the second part, for the heat transfer, another specialized software was used, COMSOL. The dryer, the general schematics of the dryer is like this. The seeds are taken from this tank. The air produced by this fan takes the seeds. This is the dryer itself. It has a conical shape, and as I'll show you later, it has some microwave generators. And this is where the dried seeds are collected. The dimensions you see here are based on the results from the simulation, and these are the physical dimensions of the dryer which was effectively constructed finally. In the paper there are a lot of details about meshing, all the details of the CFD and DEM simulations. I'm not a specialist in this, so you'll see all these in the paper. CFD was used for the gas phase model. This is for the motion of the air, and DEM was used for the particle motion. This is for the grain, maize grain. The simulation and was made for maize grains. You can see now here how the grains were, the physical shape of the grains was simulated in this software, and here is something about the grids used for the computer fluid dynamics simulations. After running the simulations, it was found that the transport speed of the seeds was 20 to 25 meters per second, and the temperature, sorry, here is a mistake, it's 44 degrees. The seeds reached the maximum temperature of 44 degrees. The humidity of the seeds when entering the dryer was something like 27%, and at the exit of the dryer it was like between 14 and 16%. The simulation has allowed us to see the velocity field in the conical part of the dryer here, and the temperature field distribution in the dryer. Also the seeds movement inside the dryer, so they don't move in a straight line, but there is a turbulent motion, which makes the time the seeds spend into the dryer longer. As I told you, 44 degrees and 500 kilograms per hour the flow of seeds into this dryer. And for the second part, the heat transfer was studied, was modeled. The heat transfer in this part, in this truncated cone piece of part of the dryer. Yes, this one from the general schematics, and is this one with the microwave generators here. These are microwave generators from free microwave ovens, which was dismantled, and the generators were placed on this part of the dryer. The magnetrons were placed here. Here we have some details about input parameters for the COMSOL program software used for the simulation. The results given by the model started from a 30-degree temperature of the seeds at the entrance, this is here, and resulted, as I told you before, in a temperature of 44 degrees here at the exit of the dryer. It was concluded that there was a part of the seeds have deposited in the lower part of the dryer, but most of them were entrained in a, let's say, spiral movement due to the shape of this dryer, and because of, let's see if I can go to the previous, Okay, because the entrance of the seeds in the dryer is tangential, so they get a rotational move when they enter the dryer. And as I forgot to tell you from the beginning, this is a research sponsored by the government of Romania. That is the code of the project, and that is the link to the page of the project on the web page of my University of Life Sciences in Iași. As I told you, these two papers just deal with the simulations. Based on the simulation, the dryer itself was, there is a mistake here, acknowledgement. The dryer was physically constructed and will enter tests, I think, in some days to see how well the results given, predicted by the models, match with the test results. And this will happen in a few days, I think, as my colleague has told me. So, okay, this again, is something missing, doesn't matter. I thank you for your attention. This is what I could tell you to the best of my knowledge about this project, because my colleague could not attend this conference. He was specialized in Germany in using computer fluid dynamics and all this specialized software. So if you are interested, I may give you his contact details and contact him directly. Thank you so much for listening and being patient with me.
Thank you so much. So do we have questions for the two different presentations that we saw here combined to one? Okay, I don't see anybody having any questions, so we will move to the last presentation. Thank you also, which is going to be a tele-presentation, and hopefully Mrs. Antonella Di Fonso, she's going to appear in the large screen.
Okay, good morning, everyone.
Good morning. Just give me a quick second to read. She's going to present the report titled Application of the Analytical Hierarchy Process in a Multi-Criteria Selection of Preferences Expressed by Stakeholders to Improve the Use of EIS. I hope I said it right. You have the floor.
Okay. Thank you very much. Good morning, everyone. I'm Antonella Di Fonso, and I am a researcher at the CREA, and together with other researchers belonging to other institutions, we present the research application of the analytic hierarchy process in a multi-criteria selection of preference expressed by stakeholders to improve use of irrigation advisory services. This presentation will be carried out together Filiberto Ortobelli, because that is a scientific coordinator of Project Opera. That is a research which this study is based. Okay, the main objective of this research is to increase the efficient use of irrigation by the application of irrigation advisory services. Different international institutions are involved in the project from which the research is based, the Project Opera project, including the manager of 4 working pages about conceptualization practical service model for irrigation. The research, in detail, the research investigates the interview preference as well as end user on 5 proposed criteria for modeling the irrigation consulting system. Interviewed are active farmers in 4 study areas, and the qualitative preference expressed will be transformed into weight by applying analytic hierarchy process that is a type of multi-criteria decision analysis developed by Sati in 90 years. So the general objective is to have sufficient information to give the final decision that will be presented as a reply to the questions that the Opera project posed to the farmers interviewed. The question is, what is the most efficient way to improve both the use of irrigation consulting services, in this case, irrigation advisory services, and water management together with providing an effective irrigation system to farmers. In this context, we identify the most important criteria, that is illustrate with letter A1, improving easily access to the information. A2, ensuring current data and data reporting. A3, improving the level efficiency. A4, improving private and public awareness. And A5, assuring economic sustainability. So we ranking of the 5 criteria according to simple feature, such as main farm activity, farm management sales channel, irrigation system, and educational level. Secondly, we develop a decision-making model used for Opera project. We regard the methodology used. The farm interview are part of 4 study area located in Italy, Spain, Netherlands, and Poland. The analysis of the questionnaire, that is 120, is analyzed by analytical hierarchy process where weight or priorities have been obtained for each criteria. So the results are interpreted by a descriptive approach, by inductive reasoning elements, where meta-analysis creating a relationship between stakeholder judgment and information collected in the database. The connection to the database is very important to interface the decision help. This allow to analyze individual preference in a group setting. So, saying secondly time, the questionnaire regarding the implementation of analytic hierarchy process is articulated and we show in table 1. Already the questionnaire are prepared for the use of the model. In fact, we see the compared criteria in the option columns, and the stakeholders are invited to use the scale of verbal judgment to express their preference. To the verbal judgment correspond a scale from 1 to 9, that is a scale proposed by SETI. So for the construction of the matrices of the questionnaire, we have used Microsoft Excel as a calculation tool. At first, it provided linguistics comparison in pair, then get numerical comparison in pair by selecting a certain numerical scale to quantify them, and finally priority, and finally we obtain a priority vector. From numerical comparison to pair, the qualitative replay relating to 5 criteria for each stakeholder interviewed are quantified by weight. And finally, the relative weight of each case study were aggregated to obtain the final weight of each criteria. In the next slide, we show the case studies. At this moment, I give the floor to Filiberto Altobelli for presentation.
Thank you so much. Any questions?
Filiberto? Okay.
I cannot see anybody having any questions. Thank you so much, Ms. Antonella. And with you and this presentation, we conclude session 3. Thank you, everybody, for attending today, and we can continue. Stavriani, I think it's you.
Εντάξει. Good morning. Now we go to the fourth session titled Society. So we start from Mr. Ioannis Betouris. The title of presentation is Research for the Exhaust Gas and Natural Gas Combustion Hubs.
Okay, thank you. Hello to all of you. My research is about the gas natural and specific combustion hubs. This research is based on devices that must run with natural gas, because here in Greece, only in natural gas must be given exhaust gas control sheets. The objectives of the investigation is to find out about the effects on the environment, comparison of flue gas emissions between the types of combustion hubs, investigates the profession of gas fuel technician, investigates if harmonized with the Greek legislation of the manufacturers of wall hand mounted boilers. Now, the data for this research was taken from the Office of the Technician Services that belong in the municipality of Larissa, and from the technicians with the necessary national license for natural gas. Why we have to measure the exhaust gas? To improving combustion efficiency, but also minimizing harmful emissions of exhaust gas into the atmosphere. Why we take these measurements with exhaust gas analyzers. The reference values must be based on Greek legislation. In a case that the measurements are outside of the limits of the Greek legislation, the technician must change the ratio of the mixture to bring the values in the limits of Greek legislation. If we want the burner to be operating well, what we have to do? For the current setting of the burner, always we have to harmonize the values with the requirements of the manufacturer. From combustion hub to combustion hub, we can find different values in the exhaust gas outlet, always based in the manufacturer values. Some of the values given by manufacturers in their project manuals are higher than the permit limits that's been set from the Greek legislation. This means two options. First, to correct the mixture, or second, to write down false values in the exhaust check sheet. If we correct the mixture, the measured values in the exhaust gas must be within the limits of the Greek legislation. The values given by the boiler manufacturer for its correct operation sometimes are altered. In this case, the correction of the mixture spoils the manufacturer values, and that means the boiler loses the smooth operation during the combustion or ignition. All this have impact to environment. As we know, the air quality affects the flora and the fauna. In living things, if the pure air wasn't good and caused health problems. Also, the exhaust gas are playing a part to the global warming. Great attention must be given to the exhaust gas produced by the combustion hubs. Now, we'll examine the data from exhaust gas control sheets. The total number of devices that we claim from these sheets was 351. 135 of them was for wall Newton boilers, 211 for floor boilers, and 5 of them was for instituted water heaters. Here, in these tables, we can see the max, the mean, and the average values per device of the most important measurements in exhaust gas. Those measurements was for the CO, NOx, oxygen, and CO2. The Greek legislation limits is for CO 90 ppm and for oxygen 7%. And in those tables, we can see that we have values for CO and oxygen above the legislation limits in wall middle boilers and floor boilers. In this table, we have the total of kilowatt, the total values of kilowatt, CO, and NOx per combustion chamber category. As we see, the well-metered boilers against the floor boilers have 11.76 times less kilowatts, but only 1.09 times less CO. Now, we will examine the analogy in CO per kilowatt for the wall-mounted boilers and the floor boilers. The wall-mounted boilers have 5,919 CO If we divide it with the kilowatts, we took 1.583 CO per kilowatt. In the floor boilers, if we make this, if we try to divide the CO with kilowatts, we will see that we have 0.147 CO per kilowatt. The wall Newton boilers have 10.768 times more CO per kilowatt. This is an important number because imagine that if we have a total 14,000 kilowatts in wall Newton boilers, what CO we will take in the air. Now about the public pool. The questionnaire was made available through the social media. In this pool take part 58 people, and the questionnaire concerned about burn installers and maintenance, with license or without license. The proposal was to answer some questions about if they use the exhaust gas analyzer, if the right values in the exhaust gas controls, and the answers that we take, first of all about them age, we found that the most of them was about the age 26 to 40. In the young ages, 18 to 25, was only 1.7%. This is a small percent. That means the young people don't want to follow this job. About the profession, we found that combustion technicians was 52.6%, and mechanical engineers is 40.4%. I want you to remind that data was taken only from Greek people. Also, about if they have the license, the 73.7% answer yes, and the rest of them answer no. In the next questions about if they have a gas analyzer, 80.7% answer yes, and the 90.3% answer no. And the question is how they measure the gas, the exhaust gas. Next question was if they use the gas analyzer in the first start. 70.2% answer always used. The rest of them is between sometimes or not at all. Next question about the maintenance was the same if they use the gas analyzer. Here we see the percent of always used drops in 52.7. That means only the half of them considers about the quality of the gas exhaust. In these slides, in the next 3 slides, I will show you what about the manufacturers of wall hand boilers want for the values of the gas exhaust. Here we have the model class 1 system from company Ariston, and we see that they seek above, they seek a CO above the Greek legislation to work properly this model. The next one is from the company Italtherm, and we see also the CO is above the 90% that the Greek legislation wants. And the last one is for company Imergas, and we see that the CO is about 160. also above 90 that the Greek legislation wants. This is not the only wall-hung boilers with above values. We have more, but I choose to show you only 3. Conclusions. The involvement of engineers in the profession indicates the small interest from the technician world in the profession of combustion technical. In the young ages, there are very small interest in the combustion technician profession. As regards the necessary license to practice a profession, a significant percent of those, they don't have the license. The flue gas analyzer is not always used in the first start of the boiler, only in the maintenance. With regard of the exhaust gas limits that given from the manufacturers, the wall-hung Newton boilers are above the Greek legislation. And as a pillage, the proposal is to research and highlight what we have here in Greece about the natural gas boilers and the technicians, and make the state take some measures to control them. Further specialized research on this issue of harmful emissions from the combustion in the hubs can be carried out in order to expand this sample and draw useful conclusions for the rest of the fuels used. In addition, it would be important to carry out similar research about the exhaust gas from larger boilers like the industry and of course all the other fuel gases. I want to thank you, and if you have any question, maybe.
Thank you, Mr. Betounis. Questions? No? So we pass to the second presentation. The title is Increasing the Use of Big Data via Agricultural Cooperatives, and the presentation is by Mr. Matteo Gresti.
Hoping you are not starving. So I have to beg your pardon because I am quite an intruder because I am a philosopher, but I promise to stay grounded. So let me take a couple of minutes to explain the framework project where I work and my project. I work in a team research. It's called Innovcom. You have the QR code if you want to discover something more. And it's a team who work in improvement, the empowerment of people who live in a rural region, in particular in a small area, quite not small, but of Piedmont region in northwest Italy, Cuneo province, which is a territory characterized by the mountains and a great presence of farm and agricultural work. My project, Agrisalus, beg your pardon for the formattation, is devoted to find the solution to problem of justice, distributive justice arising in agricultural practice, such as the access to facility as health service, as physicians. So people who live and work in the mountains, they are quite isolated and have experienced difficulties to go to the hospital, to the school. They feel like they are not socially included. So I can try to find strategies to guarantee farmers an adequate quality of life, which is my main goal in this presentation, is find new way to increase the profitability of small and medium farm. How? Keeping them updated with technology, in particular big data. I am focusing on this technology. And I'm focusing on small and medium farms because they are the type of farm where I live and I work. And secondly, because I think that they are most suitable for protecting the territory. So from an environmental point of view. Just some data. So the first data that I want to highlight is the average extension of the farmers. 71.7% of the farms are less than 5 hectares. And the other data, which is for me very important, is the average age of Italian farmers, which is quite high because half of them are more than 50 years old. In a several focus group where I was, I investigated their propension regarding use of big data and new technology. And I find that they have experienced distrust to this technology. Why? I think the reason are two. The first is high average age, and the other is consequence, because I am small farm. I have to share the data with other farms. So bigger farms can take advantage to this with this data. And I think it's not good for me to share the data. How we can solve this problem? I think that solution, we have two solutions. The first is to embrace a change in the agricultural settlement, and the first alternative is to change pass from small and medium farms toward large and big companies. But I don't want to go with this alternative. I prefer the second strategy in helping farms to become up to date with this technology. How? With agricultural cooperatives. I think, and this is the only philosophical thing that I hope to say this morning, I think that agricultural cooperatives have two kinds of benefits. One kind of benefit is practical. They can increase the use of big data by sharing the data, but also by sharing the cost and the benefit. If I participate to a cooperative with other people, even if I'm a small farmer, I can share the data with others, and I can use them and the technology that we are developing in this cooperative. And they have another benefit, practical benefit. They are strongly linked with the territory, with the way of life of this territory and the people who live there. But agricultural cooperative has also a strong philosophical justification. So this, pardon for philosophy, but they are fair. When I talk about fairness, I talk about equality of opportunity. So even if I have a really small farm, I can have the access to technology I never had if I wasn't in a cooperative. And they improve social justice as solidarity with other people, with other farmers, and allow well-being of the people who participate in the cooperatives. How? They allow the people to flourish their interest. They want to live there. They want to keep going with their job, their work as a farmer. So in this way, we can achieve this goal. And thank you for your attention.
Thank you. Any question? Yes.
Thank you very much for your interesting presentation. And I'm Maria Deliani from Agricultural University of Athens. And I'd like to ask you this. Recently, we had a research on digital transformation of small and medium size businesses, farmers, and in 3 different sectors. The problem was that they weren't aware of the technologies, for example, big data, blockchain, and all the other stuff. So could that be an obstacle of your research? For example, maybe they do not want to trust this technology because they are not aware of what it does.
Yeah, we are trying to an approach of top-down approach. We are to enforce people to use this device. Not in this project. I have in mind another project with increasing health of people who live in mountains, and one way to help them to have a good health is to use telemedicine. But they don't want to. They feel detached by this technology. So we are trying to, by the sanitarian organization, the health organization in the territory, to enforce people to use this. So it's a top-down approach. I don't know if I answered.
Okay, thank you very much.
Okay, thank you. And now we pass to the next presentation. The title is Evaluation of the Satisfaction of the Greek Agricultural Cooperatives by the Provided Banking Services by Mr. Skordoulis.
Mr. Stamatis Danos.
By Mr. Danos. Okay. Thank you.
So
we can start.
Thank you very much. Congratulations for your 10th conference. I hope everything is great. Unfortunately, I couldn't be with you physical presence, so I will be teleconferencing my presentation. Our research team comes from the University of West Attica. You can see we are 3 scientists, Dr. Drossos, Dr. Kyriakopoulos, and myself, Danos Stamatis. We have made research trying to evaluate the satisfaction concerning the Greek agricultural cooperatives. The criteria of our focus was on the provided banking services. So in the previous presentation, you heard about the importance of the agricultural cooperations. Those are some specific organizations that are owned and operated by their members and are critical for local economies. So besides the importance on local economy, those cooperations are an important player in the GDP of the countries. Specifically in Greece, the agricultural cooperations have doubled the importance in comparison with the other European countries, since they attribute 4% on the GDP, while the mean average of the European countries is around 2%. So in Greece, the leading body of the country's agricultural cooperative organization is called PASEGES, as you know. And this instrument, this organization, which was dated back in 1935, accounts for around 705,000 individuals. and it accounts for 250 agricultural cooperative organizations. So this is the main body of the country, the PASEGES. So this presentation this research investigated the satisfaction of the farmer associations, the agricultural cooperatives, concerning the banking services they receive. So this was the main criteria. More specifically, our analysis focused on the investigation of the overall satisfaction under 4 criteria that, according to literature review, can explain satisfaction of customers. Those criteria are the customer services, the human resources of the banking services, the store branches network, and the product services that they provide to the agricultural cooperatives. So our method is based on a model that is known as MUSA, multi-criteria satisfaction analysis. There is a relevant program for Windows that you can input a set of variables, and you can estimate the impact of the variables on total satisfaction, something like ordinal regression. So you have the dependent variable, which is the overall satisfaction, and you have the criteria, the 4 criteria, and the instrument, the MUSA program, can evaluate the impact of each criteria on the overall satisfaction by applying some ordinal regression techniques and some multi-criteria analysis. So I have a small introduction. I will try to be very, very brief. Harry Truman once said that in the long view, no nation is any healthier than its children or more prosperous than its farmers. So the American president believed that when the farmers do good, when the farmers prosper, the country prospers. And when the farmers have problems, the problems are moved on to the country. So as I told you before, the primary sector is quite critical for Greece. Therefore, it should be supported and get the necessary attention. So, agricultural cooperatives are looking for partners who can provide them with the necessary resources to support and assist to their production process. One of those partners are the banking system, which provides loans and several other facilities. So banking institutions have a key role for the agricultural cooperatives. They offer services. They cover all the productive, logistical, and processing needs. Most of the service satisfaction surveys conducted by banking institutions are mainly focused on determining the dimension of quality. So they focus on quality, and there is a model for measuring quality of the banking system. I have the relevant literature, and it is also included in our paper. Concerning our data, we applied the structured questionnaire. The structured questionnaire had units concerning the 4 criteria that I previously mentioned that influence the total satisfaction of the respondents. Our sample consisted of 150 agricultural associations from all over Greece. We conducted the survey electronically in 2001 via Google Forms. And as I told you, data analysis was based on the MUSA method. The MUSA method, as defined, is a preference disaggregation model following the principles of ordinal regression analysis. Ordinal regression analysis, as you know, can have explanatory variables that are qualitative. And so does the dependent variable can be qualitative, and we can estimate the impact of the independent variables of the dependent variable, which in our case is the satisfaction. So, according to the methodology of MUSA, the methodology ends up in a diagram that it's called action diagram. Essentially, it puts the criteria in a map, in a virtual map, and it warns us what to do. So if a criteria falls in the area that says here status quo to the left down side of the map, this criteria is supposed to have, according to the respondents, low performance and low gravity for the respondents, and it also has low satisfaction. So in this case, we do nothing because the criteria is of low importance for the respondents, and also has a very low impact on total satisfaction. What we are interested in is the area that it is found in the top right and in the bottom right of the diagram of the figure. The bottom right is the action opportunity. It is the critical area. Those criteria, as you can see, have low performance, have low satisfaction in our case, but are considered of high importance for the respondents. So we have to do something if a criteria falls in the area down right, the action opportunity area. On the other hand, if a criteria falls on the leverage opportunity area, we have high performance and also high satisfaction and high importance for the respondents. So these criteria on the leverage opportunity are considered to be the competitive advantage. So we're happy with those criteria. So I have a little demographics on the sample. The agricultural cooperations in Greece are mainly found in Macedonia area and are also in central Greece area. And we got a sample of 150 managers of the cooperations. The managers responded. The selection of the sample was based on this clustering on the geographical regions of Greece, but was not random. I would rather say it was convenient sampling. So the farmers guided us, and we got to the area of interest and had some responses. So this is something that maybe in a future research, maybe we have the catalog from Passages and perform a random sampling for better accuracy. So concerning the overall satisfaction of the banking services, as seen by the agricultural cooperatives, we have a very high satisfaction index. They seem to be very satisfied with banking services provided. The percentage was 82.6% scoring, and the Musa methodology can assign criteria weights to the weights to the criteria according to the responses. So in this multi-criteria analysis, we do not set the weights. The weights are calculated by the method. So according to the method, the most important criteria is the products and services, which includes the options that are offered from the banking system to the agricultural cooperatives. It includes the customer-specific products. It includes the service, if they are individualized, custom-made. So this criteria was calculated to have the greatest impact on total satisfaction according to the responses in the subset of questions. And the second most important weight was put on the store branch network criteria. This has to do with proximity, with easiness of access to the banking stores, and it also has to do with the customer satisfaction on the stores, on the banking stores, on the atmosphere of the store, of the service they have there. The two least important criteria were customer service and human resources. The calculated weights were less important than the other two criteria. So in this graph, we can see that the customer service had the lower satisfaction, total satisfaction. We can see the customer satisfaction according to the main criteria, the method of Musa calls this performance. So the most important of all for us, according to this graph, is store branch network, followed by product and services. And this is the action diagram, the action map, where we can see the bottom right area, where was the action area, if you remember. We have no criteria, so it seems that we have no specifically important problem about the banking satisfaction. On the other hand, the products and services are in the top right area of the graph. Also, the store's branch is on the borderline. So these criteria are the competitive advantage. They have scored the best. They have great importance according to the respondents, and they also contribute very important to the total satisfaction index. So these criteria are important for the banks to take care. These are their competitive advantage in order to keep the cooperatives happy. And the other two criteria fall on the left-right, bottom left area, the customer service and the human resources. Those criteria have low importance according to the respondents and have also low contribution on the total satisfaction index, the customer service and the human resources. So according to the methodology, in this area, it is a status quo. You have nothing to do, maybe. And maybe you should concentrate and take resources and put them on the other two criteria that are on the competitive side. So this was the output of our analysis. To sum up, we had a high level of satisfaction generally from the samples. The most important criteria was those of product, services, and branch network. The products and services include the variety of offer products, the provision of customized products, and the reliability. And the branch network criteria includes the accessibility to the banking service, the number of ATMs, the personnel adequacy, and therefore the network coverage. Therefore, banks should prioritize in planning the above services, according to our analysis, to further improve the satisfaction criteria, those two criteria, and to improve the satisfaction of the agricultural cooperatives. So this was our paper, our analysis. Thank you very much for your time, and I will be happy to answer to your questions.
Thank you, Mr. Danos.
Thank you.
Any question, please?
Hello, my name is Leonidas Sotirios Kyriakos, and I come from the Agricultural Economics and Consumer Behavior Lab of University of Thessaly.
Hello, Kyriakos.
Your presentation was really nice, and the subject that you presented is very innovative, and I really enjoyed it. I want to make a question. I don't know if it was on your scope, but I think that there is a lack of negotiating power when agricultural cooperatives are asking from banks to have a loan, let's say, because even in some cases that when we are implementing a program and banks are sure that they're gonna take their money back, they give high interest rates in the cooperatives, even if they are sure they have no risk that they will gain back their money. Do you have any experience with it, with how the managers?
Yes, unfortunately, yes, Kyriakos, thank you very much for this question. Indeed, unfortunately, in our country, we have a bad history with agricultural loans and the banking system. The truth is that I have a literature review in the paper, this one, because it was a short paper, but I also was wondering about what is happening on the terms of the loans. And maybe would be a future question for the paper. In Greece, the high interest rate, in my opinion, it is is offered to cooperatives because we have a bad history of not getting money back. So if you search the loans of the banking system to the agriculture sector, there is a great percentage in all banks. The first one was the former agricultural bank, a great percentage of loans that were not served. So this bad history, in my opinion, made the representatives to be more cautious, and this leads to the raise of the interest in economics. So if you're not sure, you give higher interest, you want higher interest rate for your investment. This is very bad, and I don't know how it could be changed, but it is a very nice question to have lower interest rate for the agricultural cooperatives. Thank you for your question. I hope I partly answered.
And just a last remark, in most cooperatives, at least what I have experienced, they have also very small deposits. They have very small amount of money stored regarding their agricultural activities. So this should be also taken into consideration when we are asking a loan from a bank. It's like if I go in a bank to take a loan and I have like only 100 in the bank, I can't have a high negotiation power. So.
Indeed, the agricultural cooperatives, unfortunately, their economics are not good in Greece. So, of the 1,000 members of the Pasikes, around 20 members have positive results. You should know. Only 20 members have positive results. All the other corporations have negative results.
Thank you very much.
So this is a problem that the state has to look into, in my opinion. The state has to look into and make healthy those organizations with governance, with external governance. It is a big conversation, maybe, this one, and an interesting conversation.
Thank you very much.
Thank you. Thank you for the questions.
Any other question? Okay. Thank you, Mr. Danos.
I'm obliged for your invitation. I was happy to present. Thank you very much for your time and your patience.
Okay. So, we pass to the next presentation. The title is Patterns of User Participation and Contribution in Global Ground Sourcing, a data mining study of Stack Overflow. The presentation is by Mr. Himesa Prabhakara. Who is a good? Excuse me for pronunciation.
Yeah, good afternoon, everyone. So my name is Himesha Prabhakara Vijayakorn, and I'm originally from Sri Lanka, but now I live in Prague, and I study my doctoral studies in Czech University of Life Sciences. So today I will present you the topic of patterns of user participation and contribution in global crowdsourcing, and this is a data mining study of Stack Overflow. And my supervisor is Wojciech Merunka. He was supposed to be here, but he couldn't make it at the last moment. Yeah, so I will go into more detail now. So the objective of our research is to discover patterns of user participation and contribution in global crowdsourcing using some big data analysis and visualization techniques. So I will go into more details, what is crowdsourcing and so on in later slides. But here I will describe briefly about the methodology. So we have done initial literature review focused on Stack Overflow and also some other technologies that we might need in our research. And then, after this phase, we did the technical investigation using the normal process of big data analytics, which consists of selection, pre-processing, transformation, and data mining. And in the end, we accompanied it with interpretation and evaluation of our results. So now I will introduce you what is our output from our literature review. So basically, I will introduce you what is crowdsourcing, and it is a basic type of participative online activity where a person or an organization requests a loosely defined group of people to carry out tasks for them using open calls. In simple words, it is like you ask an unknown crowd of people for some help, and they can voluntarily help in most of the cases without any financial benefits even. Like for an example, the major crowdsourcing platform we have now is Wikipedia. So you will see it's very successful, and you can get more information about anything, and volunteers run it like without any financial gain. And even recently in Athens, I used Google reviews. So when I wanted to find a very affordable, nice Savlaki place in Syntagma, near to Syntagma Square, and I found one, and then I realized there were long queue of people in the same place. So you see how the tourists and these people use this crowdsourcing platforms now. So all the reviews, like pictures, the recent menus, prices, everything are mostly updated by volunteers. So you can use this now freely. But now in our research, we wanted to find who uploads this and who uses this. So in our case, we use Stack Overflow, but not Wikipedia or Google reviews or some other platform, but Stack Overflow, because it is the major Q&A website in software industry, or like most of the software professionals know it, and they use it every day to find solutions for their problems. So for an example, these are official figures from Stack Exchange in 2015, the published figures. So they have had 101 million monthly unique visitors, and about 7.9 billion page views, and 3.7 million questions, 4.6 million answers, and 5 million of registered users. But we also realized this website is used by non-registered users like me. Like we just browse, like we type something in Google, and mostly if we come across some IT problem in programming, you get some answer in Stack Overflow. So already some other people have encountered this problem, so you can see the answer, and you don't need to type anything. You will find answers for your problem. So we analyzed how these platforms are feasible, and why it's important to have some reputation and moderation, because most of these sites are like not giving any financial benefits. So in that case, mostly the users are asking questions or are answering because of the reputation that they see, like, oh, I am a very good valued member of this site, so I can have some badges or something to show as my contribution grows on. And this Stack Overflow, they have a very good data dump. They are sharing every 3 months or so. So you can download this data dump and analyze to find something interesting. And we derived about 4 or 5 research questions, but in this paper, we only focused on the global user distribution and contribution. Okay, and regarding the technologies we used, we had to use big data technologies because this data dump, it's quite big, and we couldn't use normal ways to process this information. So it's high volume data. So we needed some big data technologies such as Apache Spark, we used with Python. And also we used a data visualization tool from Oracle called Oracle Data Visualization Desktop. Yeah, and regarding the other steps we did, so for an example, like we had two basic XML files. The first one was about 2.36 gigabytes, so you couldn't even open it in Notepad or some tool. So that's why it's qualifying for big data analysis. And this post XML file, it includes 56.3 GB of data. And then we had to pre-process this data into some XML format. This was in XML, so it's unbreakable. So like you could import them into MySQL database using some techniques. And then in the end, we found records like this. So there were 7.4 million users and 38.4 million posts. So they were finally transformed into MySQL tables. And then we also had to do some transformation. So for an example, some people have, like especially in US, they have only put the state name, not the country name. And for an example, in UK, some people have written UK and some people have written United Kingdom and so on. So we had to transform the country name into meaningful value. And also we did some aggregation, merging, and summarization. So I will just briefly go through this as we don't have much time. So now I will go into the results. Yeah. So I hope you can see it clearly. So as I already assumed that USA and India have more than 200,000 users, so they contribute 40% of the user population in Stack Overflow. And UK, Germany, Canada, France, and China, so they follow after that. But we wanted to further analyze this as because India and USA are mostly populated countries of the world. So we wanted to see how it is if we normalize this data. Like for an example, how it will be if we create some metric like users per 1,000 capita. So in that case, Europe and countries like New Zealand, Singapore, Israel, Canada, and Australia, they came up because they have much more per capita users than USA and India. So they went down, but mostly the European countries came up as we normalized this data. And then we also wanted to analyze how reputed these users are. For an example, we wanted to know which countries ask questions mostly or which countries tend to answer the questions. So like we wanted to provide this data so the software engineering community and the companies can realize, so they can even like use this data to place their companies or like have some balance between their employees and so on. So in this case, Switzerland is the top country in knowledge sharing, followed by UK and Germany. And most other European countries follow with Israel, New Zealand, Australia, and Canada. So these countries have the highest reputation as the best contributors in this platform. So they ask questions, they answer questions, so they are very active. And in the other case, Italy, Ireland, Latvia, and Lebanon, they are basically question askers. So they tend to ask more questions than providing answers. And on the other hand, Finland, Netherlands, and Bulgaria are mainly answer providers. So they tend to answer many questions. So these are also some rankings that we derived from our research. So this blue color shows the ranks within top 20. So the first column is about the reputation rank, and the second column is about answer rank, and the third column is about the question rank. So you see the Switzerland, UK, Germany, these countries have good ranks in all the aspects. But some countries are good with reputation, but not good with answer and question rank, because there is some way for the users to gain reputation by doing some manipulations, like if they are good with some manipulations, so without answering or questions or posting questions. So that is why we also had to analyze how many answers they post and how many questions they post and so on. Okay, yeah, and this is about the discussion of our results. So in both user participation and contribution, so we identified the European countries along with Israel, Australia, Canada, and New Zealand highlighted from rest of the world. And these findings we cross-evaluated by comparing with the ICT development indexes of countries provided by UN and IMD World Digital Competitive Rankings in 2017. The major difference we found, which does not match with this comparison, is the underpresence of countries like South Korea and Japan. Even though they have good ICT rankings, they are lagging behind in this platform. And the other thing we noted is also the underpresence of China and Russian Federation. So we think that this can be because of language barrier or some kind of other tools which exist in these countries. So the final conclusion is that this Stack Exchange data reveals very important patterns in global crowdsourcing, which can be very beneficial for the whole software industry. And then we also think future research is required to find factors to further explain the discovered patterns in social norms and so on, so we can cross-validate the findings that we have. So yeah, that's it from me, and thank you very much.
Thank you, Mr. Himesha. Any question, please? Okay. So, we pass to the next presentation. The title is Urbana, an innovative platform for collective awareness and enhancement of urban agriculture, presented by Mr. Nakos.
Hello, I'm Harry Nakos. I work for the Athena Research Center, specifically for the Information Management Systems Institute. And I'm going to present Urbana, an innovative platform for collective awareness and enhancement of urban agriculture. A few words about the partners in this project. First of all, this project is a Research, Create and Innovate program. It's funded by Greece and the European Union. The partners are Draxis, a company located in Thessaloniki, which operates in the field of environmental and agricultural databases, also offering consulting services in agriculture and the environment. Athena Research Center focuses on information, communications, and knowledge technologies, and is the first research center in Greece with an exclusive focus on information society. And the Information Management Systems Institute is a part of Athena Research Center and conducts research in the areas of big data and large-scale information systems. A few words about the project scope. Urbana is about urban agriculture and the creation of green cities. We focus on small-scale urban cultivations that can take place in the garden, the roof, the balcony, or inside the house. We focus on both plants used that edible plants and ornamental plants. Urbana is about a platform that's built around a mobile app that also integrates sensor data and social media data. We also provide a framework within the platform on data analytics, on cultivation data. So the objective is to improve quality of life within city limits, make the city more beautiful, provide a pleasant activity, and also help people socialize by taking part in urban farming activities. The objective is to improve the quality of the food because the quality can be is more have more the quality from the food from the garden is something that someone can manage, and also provide take a small step into the reduction of the carbon footprint. For example, leaving out transportation costs in also money, but mainly CO2 emissions. Apart from the reduction in the food cost, we can also help advance local entrepreneurship, meaning that local businesses may promote themselves through the platform. The project status. The project consists of the mobile app, which is in a pilot phase, as well is the incorporation of sensor data and the data analytics application. Social media data, specifically Twitter, is a work in progress. The software stack is a capacitor, which is used for the cross-platform development and deployment of the mobile apps that can be deployed for iOS and Android. Lumen, which is the backend. Lumen is based on Laravel and is the backend part of the framework and the mobile application. MySQL is used as a database server, and Metabase is used as a business intelligence. Metabase is a business intelligence tool that is used for data analytics. Metabase is an equivalent to Tableau, for instance, which is a well-known business intelligence product, but is open source and available to everyone for free. So the Urbana mobile app focuses on cultivations and related constructions to cultivations that can take place in the interior of the house or the exterior of the house, the balcony, the roof, the garden. It's available for Android and iOS with the name Urbana or Urbana Urban Agriculture. In the Urbana mobile app, users can create do-it-yourself projects that could be either personal or collective, created by multiple users and also managed by multiple users. The users can comment and discuss the projects and also like the projects so that better projects can be promoted further. There are two types of users in the Urbana platform. The urban cultivators is the first group. Urban cultivators have diverse levels of experience. They can be from complete novices in urban agriculture and to more professional level users that have higher experience. Agricultural consultants are professionals in the field of farming. For instance, agronomists can take the role of agricultural consultants. The user projects consist of several fields, such as the title, the description. They can also have a photo. They have the location, the latitude, longitude of the place where the cultivation takes place. the cultivation type, for instance, lemon, strawberry. Cultivation type can be free text or can also be selected from a drop-down with specific choices. The start date, the time required to complete the project, the cost and difficulty level, and meaning whether something is suitable for novices, for more experienced users, and the sensor access key is a value used to identify the sensor, the user sensor that is linked to the project, and the user sensor will be providing values, parameter values for the soil moisture of the project. We will talk about that in a while. And then the steps of the project are put, the title description of the steps, how the step can be carried out, a photo of the project status for that step, the time required, and the resources used for the project, for the specific test. Resources as tags. The cultivation practices is another part of the project, and these parameter values are given by agricultural consultants, always in the context of a specific project. These parameters consist of the cultivation type, the growing season, spring, winter, plants per square meter, whether it is the practice, the project, the specific project starts with planting or sowing using seeds, with a specific, a pre-existing plant or with seeds. The soil type, which you can see as an example in the picture, the varieties of the cultivation, a description of the pot, how many plants per pot can be used, the region of the cultivation, temperature range that would be more suitable for the cultivation, the pH of the soil, the range that is more suitable for the cultivation, the preparation of the soil, and then there are some values related to fertilization and nutrition and malnutrition, and some parameters related to irrigation. We tried to keep these parameters as structured as possible, opting for multiple values or numerical values where possible, and free text where this was not possible. Then some gamification principles were used in order to reinforce the user engagement, the participation of users in the platform. And also points are used to indicate user experience. So more experienced users will tend to have more points. Sensors will also can be used in user projects. Sensors are used to measure soil moisture. They are low cost since they are based on free and open source software, which specifically Arduino. We have instructions on the website of Urbana, which can be used for the assembly of the sensor, which consists of a microcontroller. Specifically, we suggest the use of WeMOS, which is an Arduino-compatible microcontroller, and a specific soil moisture sensor that is compatible with Arduino. We also have instructions about programming the controller and the installation, how to put the controller and with the soil moisture on the specific project, the specific cultivation. A specific sensor key is used in the programming of the controller that is then used to link the controller and the sensor to the specific project that the values will go to. The last part of the platform is the data analytics application, which is a web application embedding Metabase dashboards. Metabase can be used in Metabase queries are programmed that are transformed into dashboards, and this can be embedded into further applications. Using the data analytics application, the user can browse and analyze project data, meaning project parameters, practice parameters, and sensor measurements. They can filter the user data using filters such as the cultivation type, the growing season, the soil type, and users can view the results in tables, maps, and charts in order to view records and aggregates or distributions of the values. The data analytics application hopefully will help the users to make decisions about the current and the future projects that they will partake. That is all from me. Thank you very much. Any questions, maybe?
Thank you, Mr. Nakos. Any question, please? No? Okay. Thank you.
Thank you very much.
And now we pass to the next presentation. It's by Mrs. Sofia Anastasiadou, and the title is The Effect of Emotional Intelligence of Perceived E-Service Quality, Consumers' Perceived Value, Purchase, Loyalty, Intentions, and Satisfaction. Mrs. Anastasiadou.
Thank you very much. This is a work by me and Mr. This is a work of Mr. Stylianos Papalexandris, George Condeus, and myself. We have the period of lockdown, unfortunately, and this paper is about emotional intelligence, which in relation to loyalty, intention, to satisfaction, to purchase goods, to consumer perceived value, and the perceived service quality as well. As far as service quality concerns, we would like to see the effects on loyalty, intention, on satisfaction, on purchase, and on consumer perceived value. In addition, e-service quality is connected with efficiency, fulfillment, system availability, and privacy. These are the conceptual constructs of this component. And we would like to see the impact of these components, efficiency, fulfillment, system availability, and privacy, on purchase, on loyalty, intention, and on perceived value. So we would like to weight the website's performance in relation to overall e-service quality. Okay. Okay, something went wrong. I would also, yes, I will do. Then. presentation. Okay, full screen. Okay. Okay. So let's talk about emotional intelligence. Emotional intelligence is the ability to perceive, express, and manage emotion. Is the ability to perceive, recognize, realize, assess, and produce emotion that help the creation of sequence feeling as well as the understanding they shape. Is also the ability to regulate emotion and stimulate critical thinking. It's also a significant component of career goals and opportunities of work, teamwork capabilities, and positive relation creation, well-being as well as job satisfaction, and finally as prosocial behavior. Regarding perceived value, is related to the benefit received by customers against the price of the transacted service or the overall utility of a product based on consumers' perception. Consumers' overall assessment with respect to the utility of a project based on some customers' understanding as to what is received and what is given. And perceived value is closely related to the perception of risk and the concepts of satisfaction and quality. Perceived quality is related to customer needs that are met and customer expectations of quality are verified. The customer's judgment regarding the total quality of or superiority of the service. Thus, this work has the following research hypotheses. The first one is considered about emotional intelligence and its dimension and it examines whether are significantly correlated with perceived value, persuasion, and loyalty intention, as well as satisfaction and overall service quality. In addition, the second hypothesis, emotional intelligence dimension, conceptual constant, are significantly correlated with the website's performance dimensions conceptual constant. In addition, the third one is referring to the effect of emotional intelligence and whether these effects are significantly correlated with e-service quality. The fourth one is considered about website performance and it is significantly correlated with the perceived value, persuasion, loyalty, retention, satisfaction, and overall service quality. The fourth one is considered about e-service quality dimensions, whether they are significantly correlated with perceived value, persuasion, and loyalty intention, as well as satisfaction and overall e-service quality. And the final hypothesis is related to website performance dimension, whether they are significantly correlated with e-service quality dimensions or conceptual constructs. We have the sample of this work is 321 Greek customers, 128 of them were males and 193 were females. These e-customers fill in a Google form-based questionnaires. The method we use in order to analyze the data was the principal components analysis, the implicative statistical analysis, and the confirmatory factor analysis. We seek for the reliability measurements. Reliability measurements was made by the coefficient of Cronbach alpha, as well as by composite reliability and average variant extracting. In addition, we examine the validity of the instruments with the help of factor loadings, the average variant extracting coefficients, and also the percentage of variance. The research instrument was the TQ soft form questionnaires relate to the following components, dimension or conceptual constructs that are well-being, self-control, emotionality, sociability, and general items. Self-colv inventory was used in order to examine the service quality. Its dimension were name efficiencies, system availability, fulfillment, and privacy. We also use a satisfaction scale by 3 components and loyalty intentions by also 3 items. The website performance was measured by e-REST call inventory. This inventory has 3 dimensions, name responsiveness, conversation, and contact, and also you use the questionnaire related to consumers' perceived value, have 3 cost-benefit items, and we have our own questions in order to measure the overall service quality. As far as the reliability of the instrument, we can see here that all the coefficients, Cronbach alpha coefficient, composite reliability, and average variance explained are all very satisfied. As well as the ES call inventory. Also, these coefficients measure instruments reliability are very good, as well as ERES call inventory. Also, Cronbach alpha composite reliability and AVE has very high coefficients. The same situation is about the loyalty intentions inventory and customer satisfaction inventory. This table concerns the correlations between all the conceptual constructs of all instruments, and as we can see in this table, all the correlation were significant and significant level of 0.01. You can see the rest of the table here. So emotional intelligence perceives service quality, website performance, customer perceived value, loyalty intentions, and satisfaction scales were validated for their reliability and constant validity. There are certain patterns between emotional intelligence and consumer loyalty, commitment, and satisfaction. Measurement models fill the observed data very well. Consequently, all the extraction question models validate the measure model fit in relation to observed data, and also all the null hypotheses were accepted. This means that there are significant correlations between all the conceptual constructs of the related instruments. Thank you very much.
Thank you, Mrs. Anastasiadou. Any question? No. Thank you. And now we pass to the last presentation by Mr. George Adamidis, and the title is Consumer Adoption of Online Grocery Shopping, Findings from a Case Study in Cyprus.
Good afternoon. My name is George Adamidis, and on behalf of the research team, I'm here to present to you findings from a case study we conducted in Cyprus on consumer adoption of online grocery shopping. I will start with some introductory notes, then present the aim of the study, the methodology that we followed, our research findings, and then the conclusions. We all know that information technology has changed the way we communicate, socialize, learn, and consequently even how we do our shopping. It is estimated that more than 5 billion users are connected online using some internet service. On average, people spend close to 7 hours daily accessing the internet using their mobile phone, personal computer, or tablet. So when we refer to online grocery shopping, we are talking about an alternative way of buying food and other household necessities using a web-based shopping service instead of the traditional in-store grocery shopping. As expected, the online grocery market experienced a massive boom in 2020 as a result of the coronavirus pandemic, mainly due to the imposed movement restrictions. So in fact, while before the COVID-19 pandemic, the e-commerce share of grocery retail was 7%, during the peak of the pandemic, the e-commerce share grew to 10%, and now it seems to be stable at around 9%. So the aim of our study was to investigate consumers' adoption of online grocery shopping in relation to demographic and household characteristics, basically to fill the research gap and open a discussion about consumer behavior and online grocery shopping strategies, especially in the Rio-Mediterranean region, where according to a bibliographical survey covering the period 2000 to 2021, only 21 out of 217 articles were reporting results about consumer adoption of online grocery shopping within the Mediterranean region. Here's the research methodology that we followed. The study was based on an online survey in Cyprus using a structured questionnaire. The survey was conducted through a self-administered questionnaire that was posted online using Google Forms, and it was administered between July and September 2020. The null hypothesis tested was that there is no relationship between the outcome and predictor variables, being gender, location, age, educational level, household size, marital status, profession, and the monthly income. A total of 364 completed questionnaires were received. However, only 302 were taken into consideration for further analysis, since when the respondents answered no to the first question, whether they were the primary household grocery shopper, the interview was terminated. As shown in this figure, women are dominating, which seems to be in accordance with various studies indicating that the grocery shopping is a task mainly performed by women. Also, similar to other studies, we found that a decrease in age and increase in monthly family income were associated with an increased likelihood of online grocery shopping. No statistically significant difference was found between men and women, and likewise, to other studies, the education level, profession, geographical location, the marital status were not found to have any statistically significant difference. So in conclusion from our study, the key drivers that emerged were age and family income. With regard to age, younger consumers seem to be more accustomed with technology and internet applications, while older people are less enthusiastic. These findings might be beneficial to retailers and policymakers for marketing online grocery shopping. For example, supermarkets may opt to target older population and big households by offering no-fee delivery or promotions of discounted products to attract individuals from these groups. Definitely big life changes may trigger an initial adoption of a behavior, given the higher demand for social distancing, convenience, and/or time-saving features. But we aim to continue with this research and further investigate consumers' attitude towards online grocery shopping, the factors that enable online grocery shopping, and behavioral intention and related social norms. Thank you very much.
Thank you, Mr. Adamidis, for the time too. So, any question? And now our session is finished, and it's time for lunch. Thank you for your presence here.
Hello. Please have a seat to start the 5th session. The session 5 is for water resources and climate change. Please, let's start with our first presentation from Mrs. Ioanna Karambellia. It's about utilizing IoT technologies to reuse treated water waste for irrigation, a precision agricultural pilot case.
Hello again. If you didn't previously watch my other presentation, let me again introduce myself. My name is Ioanna Karambellia. I'm a PhD candidate student in University of Western Macedonia and the Department of Electrician and Computer Engineering. And now I know it's difficult after lunch break to take another presentation entitled Utilizing IoT Technologies to Reuse Treated Wastewater for Irrigation, a Precision Agriculture Pilot Case. Water, as we all know in this room, is essential for protecting public health and human well-being. Also plays a pivotal role in agriculture, industry, and energy production. As you can see in this picture, only 3% of the total amount of water is considered as fresh water, and approximately 30% is considered as underground. Climate change, in conjunction with increasing urbanization and other challenges, will put even more strain on land, water, energy, and other natural resources that are already stressed. Thus, an efficient and sustainable management of water resources is urgently necessitated. Information and communication technologies have the potential to efficiently support the decision-making process, laying the foundation of a water-smart society. To this end, smart management and reuse of up to now unexploitable treated wastewater in agriculture is important both in economic and environmental terms, as it reduces both production errors and costs in the production overall cycle. Now I'm going to talk about our proposed system called AVIAS and its main objectives. AVIAS develops an integrated intelligent ecosystem consisting of an innovative, easy to install and fully parameterized low-power wide area network with IoT devices that provide real-time measurements from the wastewater treatment plant and both in experimental fields, analyze and correlate collected data with reliable open data, for example, open meteorological data, and exploit advanced machine learning techniques and predictive analytics. To this end, at this point, I would also to add that AVIAS aims to support informed decision-making, optimizing the usage of treated wastewater in a safe and efficient manner for agricultural purposes. AVIAS is expected to reduce the usage of conventional irrigation water as well as of fertilizers, and also, furthermore, incentivize farmers through the incorporation of an intelligent dynamic pricing scheme for the use of treated wastewater. Also, quality and quantity of crops is guaranteed by the proposed AVIAS intelligent water management engine that defines the appropriate mixing ratio of both conventional and treated wastewater, considering crop needs, soil status, and imposed legislation limitations. Nowadays, the use of treated wastewater in agriculture for irrigation is a widespread technique and had a great scientific interest in the international literature. However, its usage has various risks related with the composition of the treated wastewater and the possible presence of pathogens, microorganisms, and pollutants. AVIAS monitors specific quality characteristics of the treated wastewater in real time, while others are analyzed in a lab from samples taken at intervals, ensuring that values are within set limits by Greek legislation. Additionally, AVIAS collects data to optimize the irrigation using treated wastewater, which are related to environmental, weather data, solid state, water safety and quality data, as well as the current soil and crop status monitored by sensors that are installed in the experimental field. Now I'm going to describe you about the pilot program, which is implemented in a field located in northern Greece near the city of Konzani, and it's a wastewater treatment plant. As you can see in the picture below, you see that the experimental field and the wastewater treatment plant is very close, at about 200 meters away. And the experimental plot is divided in 3 areas that receive different irrigation treatments. As you can see the picture above, we have 3 different areas. The first one is irrigated with conventional water. The second one is treated with treated wastewater, and there is a non-irrigated area, in order to compare the results. As a result of laboratory analysis, we found that the terrain of the experimental field is sloping, with a high difference at about 6 to 10%. The soil is characterized as a loam clay, and the soil pH is neutral to alkaline, which is ideal for the sunflower crop. We identified also 3 chemical elements like zinc, calcium, and boron in order to help us the crop development. The selected cultivation was sunflower and was selected among other energy crops due to the main 3 reasons. The first one is that treated wastewater quality characteristics are only suitable for strict irrigation. Secondly, the soil and climatic condition of the experimental area is ideal for this crop. And finally, sunflower has a relatively short developmental period, which depends, it's about 100 and 150 days. Regarding the irrigation plan that would have taken place before sowing, 2 drop irrigation systems were designed to irrigate the sunflower crop. As I said at the beginning, we have 2 systems. The first will use treated wastewater coming from the exit of wastewater treatment plant, and the second system will use conventional water from the town supply. At this point, I would also to add that when the treated wastewater does not meet certain irrigation and quality standards, then the 2 types of water are mixed in a plastic tank prior to irrigation according to an intelligent algorithm. According to the preliminary irrigation study, the irrigation of the sunflower crop will be repeated every 4 to 5 days with 21 millimeters of water and the maximum time of 7 hours according to the needs of the crop. At this point, I would also to add that we have an intelligent irrigation engine that irrigates the area according to intelligent algorithms. Regarding the required IoT equipment, we have LoRaWAN sensors that are installed both at the exit of wastewater treatment plant and in both parts of the field. We have 2 external LoRaWAN gateways, the one that is supplied by a solar panel and the other one that has a constant power supply. We use the first gateway to evaluate the performance of a novel energy efficiency communication protocol that has been developed, and the second one as a backup. Regarding end devices, we have a station for measuring the quality of treated wastewater, which, for example, measures pH, nitrate, E. coli, temperature, oxygen demand, conductivity, turbidity, etc. We have also a station at the irrigated part of the field with treated wastewater, which measures atmospheric and soil parameters, as well as an NDVI sensors for monitoring the quality of the crop. Third, we have a soil parameter sensor at the irrigated part of the field with conventional water. And finally, in order to better serve the needs of the project, we install an agrometeorological station at the non-irrigated part of the field, which belongs at the Telecommunications Network and Advanced System Laboratory of University of Western Macedonia, which measures atmospheric and soil parameters at 3 different depths in 5, 15, and 25 centimeters respectively. So, to sum up, I would like to describe the next steps and the evaluation of this proposed ecosystem. AVIES ecosystem aims to improve sustainable water management and reduce the waste of water resources by using treated wastewater in agriculture. An immediate and positive outcome of this is an increase in profit for both the wastewater treatment plant managing authorities and the farmers, as well as the quality and the quantity of the production. And another positive effect is that over-irrigation is also reduced by monitoring soil moisture and forecasting weather in order to optimize the irrigation plan. This sum all the presentation. The nutrients contained in the treated wastewater can reduce the application of fertilizers that are typically used by farmers to improve the quality of crops. A singular integrating system is already implemented and make real-time decisions regarding the irrigation needs of the field, as well as the mixing and pricing of the treated wastewater from the exit of the wastewater treatment plant. At this point, currently, the results of the first pilot installation during the first growing season are analyzed. Thank you very much.
Thank you very much, Mrs. Karambellia. Does anyone has any questions? Okay, we can move on. Thank you very much. The second presentation will be the role of systems analysis in suitable water resource management, learned in Serbia. Mr. Bojan Strajevic.
Okay, good afternoon, everybody. I'm coming from Novi Sad University Water Resources Department, Faculty of Agriculture, and I'm leading group for systems analysis and decision making. So we decided to present some of our findings recently gathered through different applications of systems analysis techniques and decision making tools in solving some specific decision making problems in water resources area. Besides that, before I proceed, I will give you some introductory notes about keywords used in systems analysis, because not all people are familiarized with systems analysis at all. This is multidisciplinary and interdisciplinary science which gathers different areas of expertise in different areas of human acting. And one is just water resources. And looking at that, water system is a system with system components and components related not only to water but to other components as well. Water resources engineering is dealing with problems related to water resources. Then systems analysis is multidisciplinary science, and in the same way, it is kind of art of gathering different engineering and scientific tools. Finally, we really need water resources engineering and water resources systems analysis to encapsulate all different problems we have in our practice. Standard methods used in water resources and in elsewhere fields are usually known as optimization, simulation, mixed methods, statistics, decision-making tools, etc., etc. All in crisp, fuzzy versions as well, and others. Regarding contemporary models, we are dealing with neural networks. We are dealing with different kinds of heuristics, genetic algorithms, simulated annealing, tabu search procedures, etc., etc. And to put it all together and to resolve the problem is something we call partly systems analysis. What is an important issue in systems analysis and on what we concentrate and learn from applications is that it's very difficult to know everything about components of the management problem, then to have knowledge about interesting areas where resolutions will be applied, which means involvement of stakeholders in participatory decision-making processes. And finally, decision-making itself, which is very complicated, which is not optimization, but this is rather weak optimization with multiple criteria, with Pareto optimum, with the different items we have to be aware of when apply specific methods. Because in systems analysis in water management, we are aware about space dimension, dimensionality 1, 2, 3, 4, even multiple dimensions in handling water resources problems. Then different scaling from local to regional to national to worldwide scale. Finally, time spans can be very different from groundwater to surface water to climate, let's say waters coming from a god. Continuity, discontinuity, and mixed space-time domains we have to handle while doing planning, managing, or real-time control. And finally, this is all part of systems analysis, to observe, to define the problem, to define goals and alternatives, to gather data, find solutions, etc., etc. More or less, we are all aware of that complex of activities to be handled when solving some problems. I selected several problems, and I will see if you have time for all three or just two of them. The first one is decision-making in water committee. There is a problem to select a good water management plan for the river basin, and this is a complex decision-making problem because there are many interested stakeholders, not only in water resources, but also economics, politics, regional authorities, or let's say local municipalities, etc., etc. And water committee, which usually will emulate all these different points of view, different expertise of people and backgrounds of people involved in the process. Some of them are better educated, some of them not, but they have very good knowledge about the problem. Then there are obstacles and there are agreements about procedures, about perspectives, etc., etc. So, for example, this is one problem. There is how to select the best plan among 5 different plans to use certain set of criteria, such as political, economic, social, environmental, and technical. And then to identify alternatives, plans, on the other side, criteria set, and decision makers. Here is a group of 3 sets of decision makers: public authorities, civil society, and water users. Water users can be, for example, large water users, medium water users, and very small local water users. Then methodology should put partners into different groups, those 3, let's say, participatory groups: public authorities, civil society, and water users. And assuming that there is some number of partners, or let's say delegates in each group, we can allocate weights to those groups. And then each member of the water committee can perform analysis of water management plans regarding those five criteria. And then to find their weights of those and try to gather all them together. For example, if we make that analysis of what was outcome of their voting or their judging or whatever method of decision making is applied, they can finally define weights of all different plans. Each plan receives certain weight. Finally, aggregation can be done by different methods. One is AHP, which is mentioned in the previous section. And if we do that, we can identify what are the best solutions, let's say the best plan, which receives the most admiration from the groups, and then to put, let's say, first 3 plans, and then continue process of decision-making with only 3 instead of 5 plans, which is very good result after some period of evaluation. This conclusion, which comes and let's say small lesson learned from the process is that two methods can identify the same best management plan for the river basin. But at lower rank positions, there can be differences about alternatives. And also, it is very good to know that different methods can produce different results. This is why system analysis may help to put alternatives in front of the final decision makers to select which method to use and which solution seems to be better for implementing in the practice. The second example is water quality prediction based on native bias algorithm, which is quite popular in water resources applications. To explore this method, we used problem of water quality parameters in 3 different locations in one river in Serbia, and then applied bias networks to predict classification of different water parameters, especially to recognize which data are uncomfortable to manage, or there are some cases of uncertainty and the bad quality of data. And traditional machine learning methods assume that data are precise, but it is not really the fact always. And Bayesian networks are quite more popular in recent years, and we are aware of further implementation of that methodology in our problems. Serbian Water Quality Index is a paradigm for this application, and what we found, it is good promise to use Bayesian networks in our further research, and we already prepare publishing some specific papers on that topic. Finally, multi-criteria analysis and optimization of finances in water resources. What we learned from the practice, there is a problem how to apply two completely different optimization techniques. One is AHP and one is linear programming. How to combine them and how to manage the results of let's say, weak optimization methodology based on AHP with the LP parameters in creating linear programming programs to solve the final balance between participating institutions in water management. We used the one regional hydro system north from Belgrade in Nadel River Basin with about let's say 83 kilometers long channel with 8 pump stations and covering the area of about 140,000 hectares. And the different purposes of these systems are analyzed: drainage, collecting water used, industrial waters, other purposes, and finally irrigation, of course. And the partners in decision-making framework were waters avoided in a public water management company, then Association of Water Users, and Provincial Secretary for Agriculture, Forestry, and Waters. And they had to differentiate attractiveness of the system, development of the systems, and cost reduction in managing the system. And after AHP is applied as a methodology, which is very simplified here because there are only 3 sectors involved, let's say 3 group of stakeholders, we can come up with the weights of these stakeholders and their attitudes towards different options in the system. And then linear programming assessment continues. Individual linear programs are created, solutions to individual programs are found, and synergistic model is created to include all 3 participants, 3 participating groups, and all their attitudes. To find that the best solution is to increase by 31% if they act separately. And what was the final result was that public water management company put the whole its effort into the segment attractiveness, provincial secretariat into development, and in a synergistic sense, water users do not to be engaged at all in that problem. It is interesting what happened in real practice. By assessing different influence, say, and power of the planet, significant positive synergy can be obtained and further evaluated if needed. Of course, improvements can always be made in further research. Thank you.
Thank you very much, Mr. Stejevic. Anyone have any questions? I think we are okay. Thank you very much.
Thank you.
The third presentation will be from Mr. Evangelos Manolas. Its title is Sociological Imagination and Climate Change, an application of Richard A. Gross problem-solving model. Okay, we'll wait.
Just a correction.
Okay.
How can I start?
Okay.
Okay.
We're okay.
My name is Evangelos Manolas. I serve as professor of sociology and environmental education at Demokritos University of Thrace in Orestiada, Greece. The topic of my presentation today is sociological imagination and climate change, an application of the Richard Gross problem-solving model. Richard Gross was a psychologist active in the 1950s, 60s in the United States, and the model he developed can be applied to several sciences, and I believe this is the first time it's applied to a very serious problem, that of climate change. And I think that it also shows what sociology as social science can contribute to addressing this problem. So really, we'll be trying to answer the question, how is sociology useful in addressing such a serious global problem? Via the model, of course. I'm not sure I can move. Who is moving the slides? Okay. Oh, thanks. Problem-based learning is active learning, which means that as opposed to passive learning, such as lecturing, really it helps students develop higher order thinking skills, such as synthesizing, collecting, or evaluating information. And usually, we ask students to try and find a solution to a real-world problem, combining their knowledge as well as their experiences. And of course, it promotes lifelong learning, which is an important aim of university education. That is, we produce people who will be able to learn themselves after they graduate. So really, when we talk about the contribution of sociology to climate change, we are not asking about how one acts as an individual. We ask how society produces a harmful social structure and how this social structure actually determines the size of the problem and defines the size of the problem. So this ability to see the larger context, the bigger picture is called sociological imagination. It's a famous sociological concept, and it was developed by C. Wright Mills in 1959. To put it in different words, to help you understand what sociological imagination is like having a picture, a photograph of a person looking ill, but we only see the person, we don't see what is around him. So if we take the picture, the photograph, using a wide angle lens, we see that behind him and around him there are factories. He lives right in the middle of an industrial area, which is really the worst place to live. So unless you see the bigger picture, your ability to decide why this person looks that way is really limited. So the social structure is really the bigger picture. Now, if we decide to use this model, there are of course other models in education we can use. We have to follow 6 steps. The first is to define the problem, then list the various feasible courses of action, then collect and interpret important data, then reach a tentative decision, then act in accordance with the decision, and then, of course, evaluate the results. Every model will need to end with evaluation. Otherwise, it's not worth doing it. So just a few words for each step before we apply it. Will everybody be interested in the problem? And is the problem important enough for the students to devote time working on it? Of course, if you don't like something, then obviously you won't work on it. You won't devote time on it. And liking something, it's an incentive of doing a good job. Then we can consider possible courses of action. It's only the beginning, of course. This activity will develop, will take a very different shape as we move through the model. We are in step 3, and this is the step of collecting information. That can be done through reading, experimentation, interviews, surveys, role plays, etc. Tentative decision will be of the various options available, which will be the best, and the class will have to arrive at a group decision, which of course may involve a compromise, as it happens usually in life, in real life. Step 5, we use community surveys, interviews, doing a play, writing letters to politicians, or designing a video or a poster. And then, finally, as I said earlier, we evaluate. And now, really, this is the heart, the bread and butter of the presentation. How can sociology help in addressing the issue of climate change, and why should people engage in such an activity? So somebody called Norgard, and 4 years ago, he said, we have here 4 questions to answer. First, why climate change is happening, how we are being impacted, why we have failed to respond so far, and how we might be able to effectively do so in the future, from now on. With regard to the first question, one question, an indicative question, which might need to be answered is why is it that the state may be unwilling to put in place economic or political incentives to reduce the problem? How is society impacted? How can climate change indirectly threaten democratic structures when corporate oil interests who benefit from continued high emission scenarios shape policy debates and public opinion? Why we are not responding more effectively? How can social context be a significant part of what makes it difficult to respond to climate change? How does social context impact people in order for them to avoid acknowledging disturbing information so that they can avoid emotions of fear, guilt, and helplessness? And how might we respond? An indicative question here is how can communities mobilize to put pressure on city governments, local employers, and federal entities? And under what circumstances, this is another indicative question to be answered, are people able to move beyond a sense of helplessness, guilt, or fear of the future and take actions that are in their collective and long-term survival interest? How do we collect and interpret pertinent data? We do that in groups. We place students in small groups, with each group covering each of the 4 questions described in step 2. And then we assign each group various activities, such as interviews with specialists with the aim of gathering additional information. And it is important that students keep a research log or journal in which they write down what they find. Really, this reminds of this sentence at the end of your notebooks there, left blank for your brilliance. That's what we ask them to do here. Step 4, reach a tentative decision based on the data. We have reformation of groups here, so that each group has an expert in each of the 4 questions described in step 2. Each of these new groups should produce and present to the class each answer on the 4 questions in a text of 400, 500 words. So really, we're talking about a page and a half, maximum 2 pages. The class then discusses the different answers, eliminating ideas that might not work. And the basic elements of these answers are written on the board. Now, the challenge is how to carry out the decision. And the decision, one idea may be to be posted in notice boards. I mean, that text students will produce, or published in student magazines, the internet, and sent to other schools. What I just said here reminds me of a professor in Britain when I was a student many years ago, 30 years ago. When he produced a paper, we didn't have internet then. He posted it, he was posting it outside his room, his office, asking everybody or anyone interested to read it and make notes underneath it. And he left it there for 2 months, for 3 months, collected the notes, and then he would proceed with publication. Of course, he would record good comments And this also happens in different ways via internet today, when it's usually a practice used by American scientists. They upload the paper widely in the internet, and they ask for comments from everybody on the planet. I've seen this happen several times. They leave it there for 6 months with a note that you are not allowed to copy it or cite from it until it is published. Now, this is a practice that I admire because they are not afraid that their ideas will be stolen. They do it. Others in Western Europe, they don't like doing this. Finally, we've come to the end of the presentation, and the most important stage is really evaluating the results of what we did throughout the exercise. So here are some indicative questions to be asked at this very important stage. What would you drop, modify, or add, and why? What were your most positive or negative learning experiences of the process followed? And what did you learn from the process? What questions, 3 questions, for example, does your text raise? How feasible are the solutions suggested in the text? And in what specific ways would your own life change if what is suggested in the text is done? So this is the application of the model. I didn't have time to apply it in the classroom because I produced the paper around May, and the semester was at its end, so I just didn't have time to apply it. Finally, then, we can just point out the important conclusions, is that our aim was to show how sociology could be useful in addressing the issue of climate change. And I believe that the application of the model provides students with opportunities to apply sociological theory, promote teamwork and communication skills. And it also emphasizes higher order thinking skills, cooperation, and self-directed learning, and builds citizen skills. That's it. Thank you very much.
Thank you very much, Mr. Manolas. Any questions? Thank you very much.
Thank you.
I believe the next 2 presentations will be from Mr. Tsirogiannis. It will be telepresentations. Hello, Mr. Tsirogiannis.
Oh, only one of them.
One presentation? Okay.
Yes.
Thank you very much. You can start. Thank you.
Okay, thank you. Good afternoon. I will present you the topic introducing kiwi fruit water footprint into a traceability IT system. Work that we have done at the University of Ioannina in a collaboration between the departments of agriculture and the Department of Informatics. Water scarcity is listed among the major global risks, and agriculture is the most significant water user in many countries. So efficient use of water resources is connected to sustainable agricultural practices. Greek kiwi fruit production is constantly growing during the last decades, especially at areas like the plain of Arta, which is among the hotspots for kiwi fruit culture in Greece. In that area, irrigation water requirements for kiwi crop are very high, so water management management is of crucial importance. Water footprint is an index that accounts for the amount of water used along a part or the full supply chain of a product. And it could connect water and cultivation inputs management of kiwi fruit cultivation in a single index. In this framework, an innovative web application which includes calculation of cultivation water footprint was developed by the University of Ioannina in collaboration with Kollios Fruit SA, a major exporter of agricultural products, which is based in Arta. Water footprint is consisted by three parts. The first one is called green water, and it has to do with the rainwater that is used. The second is the blue water. It is linked to irrigation water. And the third one is gray water, which is connected with the fresh water used to dilute pollution. Just to give you an example from New Zealand, which is a very large producer of kiwi in the world. There, they have calculated the water footprint of kiwi fruit to be about 450 liters per kilo. Water footprint has been employed for many years now as a useful tool for planning efficient water and nutrient management strategies at various spatial level. And it is already used by the agricultural and food industry as an environmental and marketing tool. The web application is designed to handle data regarding the full range of cultivation practices of kiwi fruit, pruning, irrigation, fertigation, plant protection, harvest, etc., along with data from soil analysis, weather conditions, fruit quality analysis, and yield. The cultivation water footprint is calculating, taking account all the three parameters I described previously, all the components of the index. It is just a part of the overall application. The application provides to anyone interesting traceability information regarding kiwi fruit cropping practices, as well as information regarding the water footprint of the fruits. It is consisted by two main components, the data gathering part and the data mining component, which is used for generating various statistics regarding kiwi fruit and the farms. By using the first component, farmers, agriculturalists, and traders are responsible for gathering data from every stage of the traceability chain. Those data are stored in the database and can be accessible by all interested parties. And to enhance the user experience, standard information such as commonly used fertilizers and plant protection products are already stored in the database and can be accessed via a simple drop-down menu from all the users. In the second component, algorithms are used to calculate the green, blue, and gray component of the water footprint. And on a daily basis, they calculate and store crop evapotranspiration data and effective rain. And to do that, they get data from local agrometeorological stations. Also, cultivation inputs and yield data are entered by the user. At the end of the year, the system calculates the green, blue, and green components of the water footprint according to the methodology proposed by the water footprint network. Here you can see a typical field of kiwi fruit at the plain of HAICTA, where we operate agrometeorological stations network. We have we have 6 agrometeorological stations at the plain of HAICTA and some other around it, like the one we can see in the image, and also regarding irrigation water, we use data recorded in flow meters. The calculation of the water footprint is done, as I told you, using the water footprint network procedure, and according to that, the blue crop water use is the minimum of the crop water need and the efficient irrigation. The green component is the minimum of crop water need or the efficient rainfall, and to calculate the gray water, we need data regarding the nitrogen fertilization of the crop. Also, we need the final yield. During the test period of the application, it was found that the average cultivation water footprint of kiwi fruit in orchards supervised by Kolyos fruit sign the plain of HAICTA is equal to 335 square meters per ton, which is a very good value. This application will be soon available to anyone interested through the project's website, kiwiaware.eu. And thank you for thank you. That was all my presentation.
Thank you very much. Any questions from the audience? Thank you. So let's move on. The next presentation will be from Mr. Malamos. It is about operation of digital advisory service for irrigation water management. Case study for maize and alfalfa crops in Greece. Thank you.
It's okay now? Okay, thank you. So, I'm here to present the findings of the operation of the Digital Advisor Service considering irrigation water management. We're here in Greece, when we are talking about irrigation water management for large areas, we mainly refer to land reclamation organizations, LROs from now on, that are the legal entities that manage participatory irrigation and drainage networks in Greece. So, when we are talking about efficiency in that areas, we are referring to the efficient operation of those organizations. We operate a climate-smart irrigation decision support system called IRMASYS, that covers extensive areas without requiring in situ equipment, and that assists implementation and documentation of good agricultural practices regarding the irrigation water use since 2015. That is more than 7 years ago from the first installation in the Arta Plain region. This study intends to provide information about the use of IRMASes to document irrigation practices for maize and alfalfa that were applied by the farmers of the LRO of Poros. This is located at the south side of the Ioannina Basin here in Greece, on the northwestern part. And also evaluation of the estimated irrigation timing that the decision support system yielded against the actual irrigation dates that were recorded. To my knowledge, this is the first time that something like that is presented. So, first of all, the study area. Here we have the location. It is at the south side of the Lake of Ioannina. It covers about an area of about 1,500 hectares, but only 500 are systematically cultivated. And the main crops are maize and alfalfa used for livestock feeding, totaling about 414 hectares. Considering the soil, from soil analysis, we have the dominant soil texture that it is a loam soil, about half of the area covered by that, followed by clay loam soil. And what about rainfall? We had, at the period of 2021, 150 millimeters of rainfall during the summer, during the irrigation period. So it is a rainy area. A little words about IRMASes. We installed it at Poros in 2021. It is freely available and everyone can register and use it at poros.irmases.com in both Greek and English languages. It collects, stores and processes all necessary weather, soil and vegetation data and combines it with information provided by the users, considering the irrigation events and the fields, cropping and all the information required, and provides irrigation recommendations. Also provides means for extracting information for each of the listed fields in the form of time series of effective rainfall, estimated irrigations by the model, and actual irrigations that were registered by the users. During the irrigation period of 2021, all actual irrigations were registered for every field inside the study area. Some results. On the left, there is a table presenting the distribution of the modeled, the simulated irrigations that were provided by the IRMASes without any strong calibration. We intend to calibrate, to use this data to calibrate and provide more accurate results. In the first column, we see the month. In the second column, it is the decade of the month. And the next columns are the number of irrigations. At the last row, it is the number of irrigation fields, and throughout the table, you can see the percentage of the fields that were irrigated during this date. So we had 131 irrigated maize fields, and we see that 100% all the fields needed 3 irrigations, while about 90% of them needed 4, and half of them needed 5 irrigations, according to the DSS. For 37 fields, 6 irrigations were recommended, and for one field, a total of 8 irrigations were recommended. Most of the field should have been irrigated for the first time on the start of July, before the rainfall event that occurred on the 10th. The second irrigation was estimated at the third and the first decade of July and August correspondingly, while the majority of the fields, the third irrigation period was completed during the first 10 days of August, while during the second decade, another third completed the same irrigation. The fourth irrigation was completed in two major parts. The first one from 11th to the 20th of August, and the second from 11th to 20th of September. The fifth irrigation was estimated from the 21st of August until the 10th of September, while the remaining three irrigations were intended for October. You can see that at the last row, as we proceed to the increasing number of irrigation, the number of fields decrease. What about the actual irrigations? All the fields but one were irrigated 4 times, starting at the end of May and ending at the 10th of September. The field that was irrigated 3 times only significantly delayed the first irrigation, which was performed at the 12th of July. Most of the farmers irrigated for the first time during the last 10 days of June up to the 10th of July. That is more than 70% of the fields. The other 3 irrigations, followed by the 10-day offset between them, practically ending by the end of August. Continue to the alfalfa fields. Here we see the modeled irrigation. 46 fields were irrigated with alfalfa, cultivated with alfalfa were irrigated. 100% of them needed 4 irrigations, while 70% of them needed 5 irrigations, while half of them needed 6 irrigations. For 7 fields, 7 irrigations were recommended, while for 1 field, 9 irrigations were recommended, as we see on the corresponding table. 50% of the field should have been irrigated for the first time during the first 10 days of June, while the rest irrigations were uniformly spread across the remaining days of the same month. The second irrigation was estimated at the third decade of June. And most of the fields, the third irrigation period was completed during the first day of August, while during the second decade, the remaining 50% completed the same irrigation. The fourth irrigation was completed in 3 almost equal parts, starting from the 21st of July up to the end of August. The fifth irrigation was concentrated at the second decade of August, and the remaining 4 irrigations were intended for September. And see here the actual irrigation. All fields were irrigated 4 times, starting at the second decade of May and ending on the 10th of September. Most of the farmers irrigate for the first time during the first 20 days of June. That is about 74% of the fields. The second irrigation took place after 20 days, while the other 2 irrigations followed in 10-day intervals. Conclusively, when we're considering the estimated number of irrigation, IRMASys recognize the irrigation patterns followed by the farmers for most of the fields, respecting the prevailing weather conditions and the soil hydraulic properties. For the maize crop, a 10-day delay was evident between the IRMASys output and the first 2 actual irrigations, while for the rest of the irrigation period, the irrigation matched. For the alfalfa crop, the IRMASys suggested to irrigate earlier and apply smaller amounts of water frequently. The differences can be explained since the farmer's approach is based only on traditional practices and experience. Also, it is obvious that the farmers are skeptical about weather-based precision irrigation scheduling and insist on applying irrigation based only on their established experience. Nevertheless, the calibration procedures that we apply in IRMASys can consider and will consider those practices and evolve them into valuable information for further improvement of the system, as systematic improvement of sets of parameters of crop is one of the main aspects of the IRMASys approach. Thank you. I hope that I was on the timetable. Thank you.
Thank you, Mr. Malamos, for your very interesting presentation. Yes, indeed, you were on time. Thank you very much. Any questions from our audience? I believe that is our last presentation for our session. So any thoughts from any of them?
Stand down.
I think you're okay. Thank you very much.
Good afternoon. Let's welcome you all to the final session, to the last session of today's program of the HAICTA conference. And let's go to the first speaker of this session, Mrs. Alvanou Maria, who is going to explain us her work regarding the freshwater crayfish.
Okay, so good afternoon. I'm going to present to you our really first experiment regarding the collection of pathogen-free freshwater crayfish individual and their subsequent acclimation in aquarium towards an effort for an aquaculture protocol development. Crayfish has a historical value since ancient times, and this is depicted not only as a food source for local people, but we can see here a coin from Priapos city, where in the one side is depicted the Apollo, while on the other side we can see a crayfish-like animal. So this is an evidence for cultural significance of this animal. The project is mainly focused on the region of Western Macedonia for too many reasons. Firstly, this region has 20 lakes, artificial and natural, and this is really important because this species naturally inhabiting at these environments. Except from that, this area is going under a post-lignite period, so it's really important for them to develop a protocol of farming of these species, not only for the conservation biology, but also because it has great export, it's great export oriented, and it has high economical value. So. In Greece, there is 3 native species. The first one is Astropotamobius palipes, which is not very significant for farming due to its small size. The other one is Astacus astacus, which has a wide distribution throughout Greece. As we can see here with a purple color, it is distributed from Macedonia to Peloponnese, with a recent record being in the Evia, and Podastacus leptodactylus, which is native to Evros River, and it's depicted with red dots. And due to many translocation took place, now we can find it in many lakes throughout Greece. And the two green dots are new records that it's not occurred in the past in Lake Vegorita and Lake Volvi. This species is an invasive one. It's Pasiphastacus leniusculus. We collected from Lake Agra. It has also, this is the, it has, it's not moving. Okay, it has a very specific white dot where it can be recognized. And it has established there, it has established the population. It's really important because it's, okay, thanks. This dot, yeah, here, the white dot. And it's suspected to have transferred the pathogen of Anomyces stasi that caused crayfish plague and devastated the local population. So many efforts in order to manage this species and this expansion, it's really important. So let's move to our experimental protocol. In the first photo, we can see the typical traps that are used for crayfish fishing, also from local fishermen. And in the other photo, we can see the site in the Vegorita Lake where we transferred our traps, and we left them there for 7 days before we collect our samples. We chose 3 different sites in the lake for the collection of the individual. And in total, 50 individuals were collected, where from them, the 20 were checked for both morphologically and molecularly for the existence of the pathogen. And the other 30 were transferred under laboratory conditions. And here is our aquarium. It's the aquarium place. We can see in the first picture that all the aquarium is equipped with both air pump and biological filter and shelters, PVC shelters, and of course stones from the natural environment, because hiding it's really important for crayfish in order to avoid cannibalism, and not only to avoid cannibalism, but also to be protected after a molting event when they change their exoskeleton in order to grow. So let's move to our results. Here it's a very promising result. Here we can see a female crayfish spawning, which means that produced eggs. It holds its eggs with spleopods, and it's moved it upside down in order for them to oxygenate it. Okay, here it's not a very clear picture, but if you have good imagination, you can see a male on the top and a female at the bottom. The male is hold firmly the female with its hile, and this is a typical mating behavior. And if you have good imagination, you would imagine something like that. This, of course, from another study. It's a marble crayfish, but okay, this is also a promising result for our project. Another really interesting behavior is the molting. Molting means that it's shredding the previous skeleton in order to grow. So in the first photo, we can see an old exoskeleton. It's empty. It doesn't have any animal inside. And in the second photo here, with a red circle, we can see the newly molded individual which is hiding because it wants to prevent itself and lower its metabolic rate until the new exoskeleton is hardened. And a really interesting photo as well, it's depicted here. We can see a newly molded individual holding its old exoskeleton in order to eat and absorb some really important ingredients such as calcium. And in our very last photo, we can see a familiarized individual, and we can understand this because it's very familiarized with human presence, as it doesn't go hiding and it comes in order to eat because the food is dropped every day in the same position in the aquarium. So we can understand that this project is really important, not only because native freshwater crayfish species are really vulnerable to pathogens and to overfishing and, of course, to other human actions, but the farming of these species will lead to the boost of the local economy, it will increase the production, will reduce the unemployment rates of this region, will contribute, of course, to species conservation, and we know that the demand for crustacea globally increasing, so it's really important. And these were really promising results as mating, molting, spawning, all these behaviors were observed. So thank you very much.
Thank you, Ms. Saldano. And thank you being on time. I don't know if we have any question before proceed to the next speaker. Okay, thank you. We can proceed to the next talk. I would like to invite Mr. Daoutis to speak about the application of SWOT HSP analysis in the design and construction of the forest road network. Okay.
This paper deals with the application of SWOT HSP analysis and the design and construction of forest road network. Okay. Introduction. Forest roads are the important construction for the forest, but on the other hand, they are high-cost constructions that can cause significant environmental damage to forests. According to Piccio et al., the forest road network is important for many functions, such as connecting forest area with roads. However, planning forest roads is not an easy task, as it should fulfill multiple conflicting objectives. Study area. The study area was the city of Xanthi, and in particular the forest road network of the area Gereka, Xanthi, Chimeria. Methodology. The association of AHP with SWOT contains detailed priorities for the factors included in the analysis and thus makes them comparable with the aim of improving the quantitative database of strategic planning processes. The answers were given by the authors who deals with the issue of forest roads construction and forest economics. Results. Table 1 presents the strengths, weaknesses, opportunity, threats for the design and construction of forest road network. Table 2 shows the degree of importance after the pairwise comparison of strengths, weaknesses, opportunity, threats. Positive occupy the largest percentage, 57.7%. Immediately after weaknesses occupy 18.1%, followed by opportunities with 50.9%, and threats have the smaller percentage, 8.2%. Table 3 shows the degree of significance after the pairwise comparison of strength, the ability to evacuate an area through the forest road network occupies 61.6%, followed by fire protection with 8.4%, and protection of the forest from poaching with 10.8%. Last disconnection of settlements, 9.2%. Table 4 shows the degree of significance after the pairwise comparison of weaknesses. The criterion was considered more important is ecosystem description with 61.4%, followed by high cost of construction, 27.9%, and the last of important is corrosion of the deck by high movement of water on the road with 10.7%. Table 5 shows the degree of significance after pairwise comparison of opportunities. First is the ranking is increasing the productivity of a forest area with 48.5%. Second is increasing recreation with 29.9%. Third is the development of various professions related to the forest and its functions with 14.1%. And finally, maximizing the income of residents living near forests with 7.6%. Table 6 shows the degrees of significance after pairwise comparison of the threats. The respondents ranking the possibility of destruction of infrastructure by natural disaster first with a percent of 51.2%. Second place comes the increasing risk of fire due to the increased mobility of the population with 27%. The third and fourth place were occupied by burn of the environment by the mobility of the population, 30.9%, and increasing in poaching after easy access to the forest environment, 7.9%. Conclusion. In the present work, SWOT AHP was applied for the construction of a forest road network. The results from the implementation of AHP showed that the strength as a whole is superior by 57.7% compared to the other criteria. Following are the weaknesses with 8.1% and the opportunities with 50.9%. Last of criteria as a whole is the threats that will exist during the construction of forest roads. Thank you.
Thank you, Mr. Dautis. I don't know if is there any question from the audience. No, we can proceed now to the next talk. Thank you, Mr. Dautis. Let's invite Mr. Valsamidis, who is going to talk, who is going to give his presentation called Greek Students' Environmental Attitude based on the theory of ecological attitude.
First of all. So, climate change nowadays is more than obvious. Greenhouse gases, waste, industrial and nuclear, burning of fossil fuels, etc., have changed the climate to an excessive degree and with unpleasant consequences. Direct impacts include melting Antarctic ice, rising temperatures, extreme weather and flooding, and rising sea levels. Human activities that have caused climate change have consequences for ecosystems and natural wealth, fish reduction, agriculture and livestock, health, nutrition and food, biodiversity, climate, clean water and supplies, clean atmosphere, economy and society. Okay. Global actions environmental movements, environmental theories, and policies try to provide solutions or better prevent further climate change and possibly make it possible to return to the previous climate conditions. Theories of environmental ethics are needed, which will form the basis for cultural change in order to enable the development of that behavior that will be distinguished from altruistic motives with regard to human interventions in the environment, which today reflect the highly utilitarian, selfish, and arrogant behavior of man towards it. There are several theories and approaches to environmental ethics and ecology, deep and shallow, such as anthropocentrism, biocentrism, ecofeminism, and ethics of care. Humanistic is the approach which focuses on the value of biodiversity for the people who enjoy it or experience as participants in it or benefit from it in various ways. From the opposite dimension, the non-humanitarian approach refers to the value of biodiversity per se. Ecocentrism is considered to be the view that non-human beings, things, and nature as a whole have intrinsic value, and intrinsic value is the value of one thing that goes not contribute to the value of another. The value of care emerges as the panacea for protecting the natural environment of the planet. Gilligan's theory of moral development is based on relationships, in particular the relationship self, which is directly related to the female gender and its development. Animals, according to Kant, should be treated as if they were members of the household. According to Korsgaard, what Kant claims concerns that non-human beings cannot create obligations for humans precisely because without a legislative will, they cannot legislate for them or communicate the moral laws in which they are placed as rational beings. The theory of ecological attitudes suggests that individuals that appear to share preservation attitudes in the framework of biocentric attitudes do not inevitably share an utilization in the framework of anthropocentric attitudes. So, a new theory is necessary under these circumstances, and this approach tries to contribute to this direction. We use in our methodology the well-known 2MEF scale was used to legislation and policy for operationalizing constructs. All 2MEF scale conceptual constructs named preservation and utilization were assessed using multi-item measures. And the preservation construct is conceptualizing in the following subscales named intent of support, care with resources, enjoyment of nature. Utilization construct is conceptualized in the following subscales named altering nature and dominance. So for intent of support, we have 3 items, 3 questions, care with resources, also 3 items, enjoyment of nature, also 3 items, altering nature, 4 items, dominance consists of 3 items, and we used the well-known 5-point Likert scale from 1 corresponding to strongly disagree to 5 indicating strongly agree. We also used another scale, the NEP scale, which was used to legislate the policy for operationalizing the constructs, and we also used preservation and utilization. In this scale, preservation conceptual construct is constructed by 10 items. Utilization conceptual construct is constructed by 10 items also, and we also used for this NEP scale the 5-point Likert scale. In this survey, 369 students participated. 174 out of them were males, and 195 were females. We used this hypothesis. We see in the slide the 2MEF scale is a second-order model. The the NEP scale is a first-order model. Students' attitudes are strongly correlated with biocentric pre-environmental attitude. Students' attitudes are strongly correlated with human-centered and environmental attitudes. Female students have statistically higher perceptions for the preservation attitude than males, and female students have statistically higher perceptions for the utilization attitude than males. And the results, we used confirmatory factor analysis and principal component analysis as well. So this 2MEF scale was examining whether it is a first or a second order model scale. For the valuation of the factor structure of the model of the two measurement scales, we used the good fit index, chi-square over degrees of freedom was used, which was less than 2. The CFI stands for comparative fit index, the GFI for goodness of fit, AGFI, comparative fit index, and the RMSEA, root mean square error of approximation, were all satisfactory, which satisfied the structure of the exported factor model resulting from the use of the 2MEF and NEP scale. So we see the values for the results for these factors, and we see also the result for this is where for the first order, and these results are for the second order model. The results which satisfied the structure of the supported second factor model resulting from the use of the 2MEF scale, two first-order factors or conceptual constructs named preservation and utilization, and 5 second-order factors or conceptual constructs named intent of support, care with resources, enjoyment of nature, dominance, altering nature. We see also the results, the values for the first-order factor model, and also the result which satisfies the structure of the exported first model resulting from the use of the NEP scale. NEP scale was a first-order factor model related to two factors or conceptual constructs named preservation and utilization. And the principal components analysis, the second technique, we used the 2MEF scale as well as NEP scale reliability. It was estimated by Cronbach alpha coefficient, as well composite reliability and average variance extracted with CR and AVE respectively. Cronbach's alpha coefficient for 2MEF scale counts 0.987, and its conceptual constructs named preservation utilization Cronbach alpha coefficient is above the cutoff point of 0.70. Cronbach alpha for preservation and utilization equals to 0.1814 and 0.865 respectively, values which are greater than the cutoff of 0.7, so they are considered as very satisfactory. We also use the Cronbach alpha coefficient for preservation subcategories, named intent of support, care with resources, enjoyment of nature equals to these values, and which are greater than the cut point of 0.7. And also Cronbach alpha coefficient for utilization subcategories named dominance and altering nature equals to 0.930 and 0.777, values which are greater than the cutoff point of 0.7. So they are considered as satisfactorily, respectively. So the composite reliability for preservation subcategories, the same name, intent of support, care with resources, enjoyment of nature equals to these values, respectively, and these values are greater than the cutoff point also. The average values greater than cutoff points are considered satisfactory, and composite reliability for preservation subcategories names dominance and altering nature equals to 0.912 and 0.852 respectively. So these values are also greater than cutoff point, which is 0.7, and we also see that AVE is equal to 0.843, and 0.58 for dominance and altering, respectively. And the follow indexes named eigenvalue, percent variance, loadings, and communalities are accepted for the revealed the constructive validity of 2MEV scale. And the measurement model fits the observed data. We see the values. And okay, Kronbach alpha coefficient for NEP scale. We see also some values. I go to implications and conclusions. The study examined whether there are differences between the two genders, male and females, with t-test. It was found that the attitudes of the girls were statistically higher for the preservation and related to NEP scale and lower for the utilization factor. We see the values. So, conclusions and implications. Students may have either a biocentric pre-environmental or a human-centered environmental perception, but not at the same time. Students treat biocentric preservation, anthropocentric utilization as separate and not necessarily relevant features of environmental perception. The NEP scale places respondents consistently from a biocentric to human-centered global perspective, NEP to DSP respectively, and students who may have either a biocentric, pre-environmental, or anthropocentric at the environmental perspective, but not both. Students also believe that although it is certainly understandable that one could have a high rating for consideration, indicating a strong desire to protect the environment, but at the same time claimed that the primary purpose of the environment is to benefit people, also resulting in a high score in utilization factor. The theory of ecofeminism, the theory of ethics of care, including the Kantian ethics regarding the treatment of animals, if they come to a synthesis, may possibly form a multi-layer and multi-dimensional framework through which rational beings will be able to give analysis, assessments, and even solutions to the complex issues regarding human life, external human life, and the natural environment, and to create the culture of love for nature and an ethic of care taking into account the agenda of the principle of sustainable development. However, the role of politics and environmental policies internationally that focuses on climate change is extremely essential. There are indirect duties of humans in relation to animals and plants through which well-being, not rights, are conferred, which additionally include extensive aspects of nature, various rare or non-rare species, habitats, including biodiversity. Future research may expand the aim of the issue to other countries and different cultures, and different environmental policies, different industrial, more special tourism and hotel industrial development. Big data applications, pipeline dynamic scheduling of big data streams, and algorithms and new technologies can offer an assist to gather and analyze a large amount of data related to tertiary university students. Thank you very much for your attention. I'm sorry for
Thank you, Mr. Valsamidis. It's not okay, it's very close to your time. Thank you, Mr. Valsamidis.
Thank you.
Is there any question? Something? Yes, please.
Yes, it's you.
Of clarification. Why do you think that preservation and utilization models are against each other? Because the preservation is a biocentric model, because to preserve the nature is also a task of anthropocentrism. I speak as a philosopher, because if I establish a national park to protect some species, and so I have to put borders that are human construction. So it's not biocentric as approach, but anthropocentric as approach.
So it's always a trade-off that we cannot be absolute in these theories. People have imperfections, so sometimes they act with both roles. So they think differently when they face something from themselves, from their point of view, and think differently if it matters someone else. So maybe this is an explanation from my point of view. But sometimes people also change what they are thinking all the time. So it is hard to believe and we can be absolute to this theory. This is my point of view.
Thank you again. So we can proceed to the next talk, which is going to be held by Mrs. Selim Kanan. I think it's going to be virtual. Thank you. Welcome, Mrs. Kanan.
Thank you. Ladies and gentlemen, welcome to the conference. I will present you transhumanist farmers' perception of climate change and the Mediterranean region in Turkey. I'm joined from 19 Mayıs University, and climate change affects agriculture and is affected by agriculture. Transhumanism is one of the most vulnerable activities in livestock production systems and the most affected by climate change. As a result, developing and implementing climate change adaptation plans and regulation is critical in order to forecast the effects of climate change and limit or prevent them. Scientific research on climate change that incorporate observations, data, informations, forecasts, indicators, and evaluations are required. So, the aim of the research to benefit from the development of sectoral climate change strategies and action plans, transhumanist farmers' perception of climate change, observation on climate change, and climate change adaptation methods were questions in this study. This research area was carried out in Silifke, Aydıncık, Erdemli district of Mersin province in the Mediterranean region in Turkey. Data collection was carried out in 2020 summer season. Complete count sampling method was used to select the respondents for transhumanist farmers face-to-face questionnaire survey. Direct observation was done in potential seat of Silifke and Aydıncık rural municipality to acquire in-depth information of biophysical change, challenges, and local adaptations measures for the seasonal movement cycle. The data analysis was done both using qualitative and quantitative method. Likert type scale was used to measure perception on climate change and adaptation strategies. And the average of farmers was 60. Their education level was primary school, and 30% of the farmers were illiterate. And nearly 29% of farmers made decision alone, 57% with their families, and 14% with the influence of the social environment. Average household size was 8 person. Approximately 29% of farmers were engaged in crop production besides goat farming. The average pasture areas where they grazed were 66 decars of households. Most of transformers farmers did hear and were aware of climate change over the last 20 years. And 29% of transformers farmers were using smartphone and radio as primary information source for weather forecast. The transformer system, which relies entirely on natural resources, is more affected by the impact of climate change. Most of farmers acknowledge that there is a severe rise in temperature and extreme weather events. All farmers perceived an increase in the temperature and decrease in rainfall. Transformers farmers perceived the drought, a decrease in water resources. Also, farmers perceived a decrease in biodiversity. 57% of farmers perceived decrease in the number of predator actors, attracts, and 71% of them perceived decrease in the number of bees and insect populations. The rate of farmers who observed and did not observe the decrease in natural rangeland, grassland was equal. Despite these alterations, the migration path, duration, and time have remained same. Although the farmers did not perceive the incidence of natural disasters as the effect of climate change, great fire disaster occurred in the Mediterranean region very soon after the data were collected. All farmers note that there has been a decrease in annual rainfall. Also, they note that there has been an increase in amount of rainfall in summer and a decrease in amount of rainfall in winter. Many farmers reported change in duration of the drought, hot days and cold days. Knowing that most of farmers observing the impact of climate change, we explored those perceived risks to their production system varies a lot. We asked the farmers who stated that they had observed change in the climate in the last 20 years to indicate the adjustment they made in their farming activities. Adoption strategies of transformers farmers mostly involved change in feed operation practice and selling livestock. Most had adjusted their management of farming resources to climate change with biophysical and farm operational adoption measures. They optimized feed storage, add supplement to their ratio, stored water, and sell livestock. The research findings are in line with the studies of Rayamaji and Manander in northern Nepal and Aryal in the Himalayas. In the both studies, transformers farmers perceived change in rainfall, temperature, water resources, drought, incidence of natural disasters. And the farmers reported change in amount of annual rainfall, winter rainfall, monsoon rainfall, duration of the drought, winter temperature, and summer temperature. This study highlighted the transformers farmers' perception of climate change and which adoption strategies they are considering. Almost all farmers observed both the frequency and severity of extreme climatic events such as drought, heat, and unreliable rainfall, reflecting actual threats in rainfall and temperature in the study area. Although most transformers farmers who are active observe of change, climate, and ecosystem, recognize the risk associated with climate change. They were not diligent to consider adaptation strategies other than selling livestock to sustain their farming, which further contribute to their low adaptive capacity. While selling livestock seems a quick return subsidy, the risk of the decreased livestock production and food security is disregarded. The major issue with this innovative approach is the risk of sustainability of the transhumance production system in the future. Regional adoption actions could be established as first step by identifying water and pasture availability for future migration routes. The decision-making process of operations will be supported by using remote sensing, smart weather stations, artificial intelligence, and high-performance computing technologies in water and rangeland management. Against forest fires that directly affect transhumance farmers, climate change adoption should be integrated into biodiversity-friendly afforestation and reforestation guidelines and future forest strategy. Data measuring disaster losses as a result of climate change are insufficient. Thank you for your attention.
Thank you, Mrs. Kanan. I don't know if there is any question. Thank you, there's no. So let's let's proceed to the final talk of this session of today's program, which is going to be held by Mr. Martin Rod, with the title Archimate Meta Model for Environmental Management System ISO 14001 Standard.
I will share my screen in a moment. I hope you can hear me and you can see
we
everything.
can hear you.
Awesome. I will put this into background. Okay. So it is a pleasure to be here. Still, we are teleconference, but I am hoping that you are enjoying your stay at Greece in Athens. I am saying a greeting from Czechia, and I would like to, ladies and gentlemen, today present the topic about the Archimate meta modeling. So let's get to it. Okay. So first question is why? Why would we want to do this kind of endeavor to map some ISO format, some ISO standard to Archimate? So the motivation is henceforth, the first part is the importance of the standard itself. There are currently many issues, pressing issues dealing with European Commission, like Green Deal in Western countries. Of course, somehow shameful, the energy crisis that is encroaching upon us due to some political, I would say, mishappenings. And of course, there's a consumer perception of the companies. That is linked to corporate social responsibility, which of course has an effect how many peoples are able to buy and of course select your stuff to be your goods to be purchased. So importance of enacting and using and be in compliance with the ISO standard is one way to show that you are environmentally responsible, you are using your resources effectively, and that means And you can, of course, get some certifications, but this is probably just a byproduct. So that would be one part why use the standard or be in compliance with it. The second one is a question why using Archimate. What is even Archimate? For some, it could be a new, I would say, topic, but I can definitely tell that the Archimate is a language. It's an open standard based to ease the communication from the top hierarchy of a company to its, I would say, underlying structure. And of course, it's heavily tied to applications, so to like running the technological stuff, the servers, and so on. The thing is that the Archimate can and is written in a form that is, I would say, easily computable, computable, accessible. It's like really a computer language, I would say, but it is a good tool to use in idea sharing between the business. So it's not just like for the programmers. For just like brief example, this is this language structure of the Archimate. There are some layers, there are some building blocks. I will just show you a trivial example. In here, that some researcher writes an article, right? So that means this is some active structure. This is the behavior, what is enacting, what is doing, and what happens. Of course, this is a wrong example, right? Because of course, any researcher like me or you first doesn't start with writing articles. He needs to do some research. So he starts with researching, then he writes some article, and the article could be maybe published. I hope so. So the thing how to get from the meta model, it is a process, and I, based on the literature review, started with the ISO standard with a bilingual version. One was the standard implicit language of English, and I used the Czech standard as well, the translation. And I selected the scope of the terms and definition that would be then used to build the meta model. I didn't then just skip the Archimate model. That could be maybe a quicker path, but it would be I would say less precise. So firstly, I selected and built an UML domain meta model, and that meta model was assessed by Bunge van Weber ontology. Why I did this? It's because if you have some text and you need to conceptualize it into, like, I would say, more IT terms, you still need to look at the ontology. If there's no change of the meaning of you were thinking that the text means, but in your UML model or Archimate model, it means something else. So it's just like a cross-reference how to say that you have done it correctly. And after that, you can basically map the model to the Archimate. So from the UML one, you go to the Archimate one. This is the process. Let's look at some strong or weak points. The scope of the terms. During the process, we have been challenged to combat the terms with definition, but there are some terms that could not be made as I would say domain aspects, as a class diagram, but they have to be modeled as a relationship one. And some problem or some challenges were that some terms were defined but out of scope. That would be like, there's an example of external organization. It was defined, but then the standard just says, okay, this is out of scope. You don't need to work with it. However, I still kept the external organization in the meta model because the underlying structure and other elements were, of course, linked to this external organization. And it also works pretty well with the Archimate concept of and TOGAF concept of extended enterprise. And the biggest obstacle, I would say, was the gray ones in here, like terms that were used throughout the standard, but no definition was provided. So to solve this issue, I looked into other standards and tried to make sense of these constructs, if they are the same or different. So some new 5 elements were added to that meta model. This is the UML meta model. It's too small, so let's go to some part of it. So this is the zoomed one part of the meta model, which says that there's some organization. This organization, of course, has some competence. That means it could be linked to CMMI, like meta model maturity, meta model assessments. Of course, this is the environmental policy. So organization has to abide and make one environmental policy. And of course, the organization is trying to achieve some objectives. And these objectives, of course, have some kind of environmental aspects. So in order to do so, the objective, of course, is then made of some environmental objective ones. So this is like the domain specific. So this was like the UML model itself, but that was not still done. In order to go from the UML to the Archimate, you still need to map these elements. The UML, and that's why I started with it. It's much broader. You can use like everything you need and you want, but then you need to map it to Archimate, which has the semantics, different semantics in the relationships, in the elements. In the UML, here, this is just some kind of rectangles in layman's terms, some classes. But in Archimate, every class has its semantics. So it's some kind of like business actor, there's some application, and it looks different and it behaves different. So in order to map it, there are like 4 situations that can happen. Of course, the easiest one would be if the Archimate and the ISO was complete. So every element of the Archimate could be paired with the ISO one. However, in multiple instances, there was a case of overloading. So some Archimate elements are mapped to one or more elements in the ISO standard. And of course, there's a problem if there redundancy occurs. There's on the right side, this is the case of there's a process. Of course, in the standard there are more processes. There's talking about auditing, monitoring some stuff, measuring, but all of these business processes are of course like just a realization, just a different like they are inheriting the aspect of the basic process one. So it has to be modeled as such. And via that, we can then use like the whole Archimate meta model. So this is the whole of the concept, which can be then used by the architects and used by I mean, of course, they don't need to use all of this stuff. They can just look, okay, there's a problem. We need to get our objectives together. And they would know that the organization, there's some top management alignment and the environmental policy alignment. And of course, I would need to look at my competence at the organization. So it could be linked pretty much all together. And it is a good accelerator to just go from I need to implement a standard to, okay, I need to find objectives. I need to name them. I need to put them to our policy. And then if everything is aligned, then I can say, okay, if I need to use the certification for the process of environmental management systems, I can gladly go through it and I will get it. So this is it. This is just another view how the elements are grouped by the chapters, but this is not still the end. There are many further steps. This is basically a valid meta model from the theoretical point of view. However, I would like to verify it in practice. So put it to use with other Archimate users, not just the 2 I discussed it with writing this paper. And of course, use it with the conjunction of the practitioners of the environmental management systems as well. And another stuff what could be done in the future is creating meta model usage improvement in 2 ways. First one would be the creating specific viewpoints. I already talked about it a little bit earlier. And the second one would be developing more domain-specific meta models for example, like e-government stuff for small and middle enterprises, or maybe like telco versus, I don't know, banking or something like that. So thank you for attention. That's all from me. If there are any questions, I would like to, I would be happy to answer them. Thank you very much.
Thank you, Mr. Rod. I don't know if there's any question. Okay, thank you. I would like to thank you all. This was the last session for today's program, and also to remind you regarding tonight's dinner, which is going to be held at Ventiri Grill House, which is on Ventiri 5 Street, and also to inform you that at 8:15 tonight, we're going to begin by walking from the lobby. So the meeting point is at the lobby of the hotel at 8:15. Thank you all.